All right, guys, so we're going to continue what we were doing a few nights ago. We were looking at the skills that we need, the kind of entry points into getting into Linux as a career. We're going to continue on the set of labs that we were working through. Basically just labs from start to finish, and then I'm kind of adding color commentary as we go. So we are in, we're going to do lab 5 here, which is going to be connecting to systems and pushing or pulling files, because these are tremendously useful skills in the Linux world. You are going to be connecting in from, a Windows or a Mac machine, or maybe you get a Linux desktop. Most companies are not going to support a Linux desktop to 1 or 2 users in their engineering space. So a lot of times you're going to be using a Windows or a Mac machine. So you do need to understand how to connect and get into Linux, which most of us, I think, kind of know how to do, and you can use PuTTY, and there's all kinds of terminals. I'm not going to tell you any one terminal you have to use or whatever. But once we get in there, how do we get the stuff that we're doing? How do we get anything bigger than like one screen worth of copy off of the screen and out into some other format? Like we have to send, Xshanya, how's it going over on YouTube? Yeah, like how are we going to get what we're doing out of the system and over to the management or the auditors or the government regulator, whoever we're talking to, right? Whoever it is that we answer to in our company or our contracting sense, we have to be able to get stuff out of the system, because, I mean, you can't put them at a command line. These people aren't going to understand that one bit. So what we have to do is we have to know how to pull and push data around in our network, right? The data are existing in all these different places, and we need to be able to move that data where we need it, right? So let's look at that a little bit. Let's see kind of some of the tools that we have and all that kind of stuff. Xshunda, you want to know about a good place to start reading up on Slurm? I would start here. If you're using Slurm, it would be SkedgeMD Slurm. That's the management tool. And we have a lab on doing Slurm, but this is where I would start it. If you were telling me, hey, I want to get into using Slurm as a tool. Slurm is a scheduler. Wildfi over on Twitch, how's it going? Yeah, Slurm is a scheduler for HPC systems. Basically what happens with HPC is we've got a big giant supercomputer, right? And we have to keep people, we have to give people access to it, right? We have to trust some users. But then those users have to, they can't just run things across, like run bash commands across the whole cluster. We have to give them basically like an input terminal where they can send commands in and stuff and workloads and all that kind of stuff into the cluster, right? That's what a tool like Slurm or Platform LSF or LSF or OpenLava or PBS. PBS is a big one. And these are places where basically we can give them a login or a terminal or a system, and they can submit jobs. And then the job scheduler, which is what that tool is, will fan it out to however many open machines meet the requirements of CPU and memory and all kinds of other things like that, right? Marco Gonzalez said, good morning, happy 4th. Yeah, it is the 4th of July. Happy 4th. Happy birthday, America, right? All that good stuff. So that's good, right? Xshenya said, so I hear ML circles, it's Slurm or bang your head with Kubernetes. Yeah, well, and actually Slurm works with Kubernetes now. I need to do a little bit of presenting on that for people as well, Xshenya. But I think that starting out with Slurm, you can do it over here. We'll probably get to our Slurm lab here today, and I'll show you guys how to set it up. But Slurm has a tremendous amount of functionalities and capabilities for submitting jobs into a cluster and that kind of stuff, right? It maintains that part of it as far as the difficulty of running a supercomputer. Supercomputers have a whole bunch of components. I have them kind of listed here, right? And it's the HPC components that I mostly work with are compute nodes, right? You got compute nodes doing stuff. You've got your cluster management systems. That's what's maintaining all of your cluster. Then you've got your schedulers, which is what we were just talking about. Schedulers are how jobs get submitted in properly so they don't step on each other, they don't break things. They exist within the rules of the cluster. People aren't just running stuff on different nodes. Then typically we have big shared storage and storage devices and those kind of things. And then we have different types of networking. We have both management and external networks, and then we also have internal high-speed networks that we use for our back-end storage and all that kind of stuff. And then we have, this would be HPC tooling, or I kind of want to rename this as like user productivity, because HPC tooling, oh, just knocked my thing off my mouth, or my speaker. So anyways, ML tools are like, how do we allow users to interact, and what tooling do we give them? And one of the things that we do a lot in here, I actually need to include it down here, is SPAC. So like SPAC is this tooling, and I might take monitoring here, and I might move monitoring out to be its own thing, because monitoring really is a big deal when we want to meter the connection and understand how much users kind of interact with the system and that kind of stuff. So okay, so anyways, that's kind of that was just a specific question we had about Slurm. So that's where I would get going with Slurm if I was trying to get into that. All right, so the lab here, I'll link the lab to anybody that wants to start it. It's our 5th lab. We did not make these labs in order. This just happens to be 05, which are more of like the admin and look around type labs. But it says right here, you are a new administrator and need to connect from the main jump server to another server in your organization. You realize you need a better understanding of the SSH connection process. Connect to the other server and look at the specifics of the SSH connection. Now, when you do stuff, especially like as an admin as you first start out, SSH is just a way that we connect to servers, right? It's a thing to understand from like a high level. I know that I say SSH and then dash and any options that I have, and then at the end I give the connect string of the device that I want to connect, either via IP address or DNS name or cluster DNS name, whatever the short DNS or full DNS. I can do all these things to connect, right? Well, maybe in our case we're starting to become more of an engineer and work on this stuff and build this stuff, and now we need to understand a little bit more about like what's going on under the hood. So we're going to connect to the other server and look at some of the specifics. So we're just going to SSH to node 01 to start, and we connect over, no problem. Then we're going to type exit, and we're going to leave and come back to node 0, or back to control plane, which was our jump box in this case. And that's cool, right? Like everybody can do that. Everybody's done SSH somewhere and exit out, right? But what if there was a problem? What if something broke? What if we needed to dig in a little bit? Well, there's debugging tools inside of the SSH client that'll allow us to see what's going on. So we're going to add 1V for one level of verbosity or one level of debug to this process. So I'm going to do SSH-V node 01 uptime. And now the whole screen exploded. Look at that. It's like a mess of like, instead of one page, that's like 2 pages worth of data, right? Just coming out to the screen. So let's go look at what happened here, right? In our SSH, as we started SSH over to node 01, and we gave a command argument, so it's just going to connect, run the command, and leave. We see that we started up the client, OpenSSH 9.6 P1. We see that. We're reading the configuration data from etc SSH underscore config. So that is a generic configuration for all SSH outbound clients connecting from control plane anywhere out, right? That's a default one. Now, if you had one inside of your home configs, it would also try to read that. Like if you had one in home, your username .ssh, it would try to read that as well here. But then it comes down here and it's going to try to connect that to that node, and it's done a DNS query right here. It's had to do, well, it's either done a DNS query or found an Etsy host, but for this part, it's going to hand off to like its NSS scripts to go and figure out, because how else would it know that node 01 was 172.32.2, which by the way is the actual way IP is going to connect to it, right, and talk to it in the network. We're going to use port 22. And then we're going to come down and it says that the connection is established. So we went over to there and almost like doing an NC with the node 01 and then 22, we have a connection established. So we have probably at this point gotten a header back from the OpenSSH port on the other side. And now our system here locally is going to start looking for identity files. And the first identity file that it looked for is root.ssh ID underscore RSA, and it got the answer 0, meaning it found that file. Then for all these other ones, every other one of these here, it got a -1, meaning it did not find that file. And most of you, if you know me, you're going to say, well, Scott, anything you say, you try to prove, right? So I'm going to prove real quick that this is the only one that exists in there. Well, how would I prove that? Well, I would go to that file system. So I might come over here and then just skip right here real quick and say ls-l in root.ssh. And I see an ID underscore RSA and an ID underscore RSA.pub, and then an authorized keys and a known hosts. And ID underscore RSA was found, so good. And all of these other ones, all these other IDs do not exist there. You see that? So we just proved to ourselves that is what's happening within the system. And I often tell you guys when you're learning something and you're seeing something for the first time, hey, Julius Caesar over on the YouTube side, hopefully this stuff's useful to you. We are just going through one of the labs for Killer Coda, and I'm just kind of explaining a little more of like what you're looking at. I mean, guys, you can do these labs and look, you can just blast through them. Look at all the commands on the left. You can just hit enter, 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 finish, and congratulations, you're basically a Windows admin, right? But no, we're digging in a little bit, and we're proving to ourselves the things that we think we understand about this system. And in this case, we proved that this is the only file that we found on our system. All these other identity files don't exist, right? Okay, so we come down here. It says local string version. That's what's coming from the local side. And this is the header that we got from the far side, right? And if we wanted to test that that was the version that we saw on the far side, we might come over here. And like I said, we would do a net connect node 01 on port 22. And look at that. There's our network connection. There's our header, which is what this is reading for the remote protocol version. Because how else would, I mean, think about this for a second. Just think for 1 second. If you were calling across like an empty open room, right? Which is basically what this protocol is doing. It's calling to a node on the far side. And you don't have any idea who's on the other side of that room, right? But somebody responds from the other side of the room and they tell you who they are, right? They say, hey, I am whoever, right? Well, you would, if you trusted them, which systems implicitly trust each other, right? That's like a trust mechanism here. We are getting this information from what we saw in the header of the remote machine that we want to connect to, if that makes sense. And hopefully that makes sense, because that's I'm showing you that's where we got it from right there. If we tried to connect to a different machine with a different protocol header, we would get whatever that header was. If we went into node 01 and we modified this header that it was going to show, if we went in and recompiled its SSH daemon, which we could do, right? We could recompile that daemon with a different header here, and we would not see that right here anymore. We would see whatever that new thing was that we had compiled. And this is actually a security consideration to think of. Some companies leave headers very open for connections, and then you can tell everything about what's going on. Some do not, right? And you can see that behavior if you go scan open websites and stuff like that. I'm not telling you to do that, but that is websites and open ports out on the world. You can see which companies leave headers open on web pages and open ports and other ones that don't. And that's a security posture. That's a security consideration of if somebody calls out to you in the dark, are you going to call back and tell them, you know, your posture and your loadout and whatever. And some people would immediately say, I'm not telling them nothing. Well, welcome to the internet, right? And then that's so this is a consideration for you guys from a security standpoint, right? All right, so anyways, then come down, here's the banner match, and then we're trying to authenticate over there as the root user because that's a user that we're handing over. And then we can load the known host keys and validate that that user is who it says it is, right? And then see if they match and all that kind of stuff. And then we just keep walking through. We start to exchange what algorithms and keys that we will use, what ciphers we'll accept and not. And if you ever start locking boxes down, especially according to like FIPS standards, what you'll find, and you guys want to see the FIPS standards I'm talking about? Sometimes I show these, and sometimes, FIPS can get, STIG in general can get to be a little deep for entry level. I'm not trying to make you guys, deep security experts right now, but this is something I do often throughout the day, is when I'm hardening boxes, right? Say I go to RHEL Enterprise 9 here. By the way, these are the DISA STIGs. You can find them on the web. They're free. The government produces them. The U.S. government produces them. So if I go right here, and let's look for Mac, right? And we can come down here. We're going to find the word machines too, apparently. I want like the Mac algorithms that SSH is going to use. Yeah. So here's the configured crypto configurations that we're going to allow. And as of April 2nd of this year, which this is the most recently published RHEL 9 STIG, which is the Secure Technical Implementation Guides, this is the ones that you're allowed to use. These are the ciphers that should be used. Anything older than these ones should not be used. So, Xshunya said, random compliment before I go. You're quite generous with your knowledge and having patience with the community. Well, Xshunya, the fact is I have very little patience with anybody. No, I'm just kidding. But I do try to show you guys this stuff because I want people to understand that this stuff is not so hard that they can't do it. If anything I'm doing looks like I'm doing it fast, it's because I've been doing it for a long time. It's not some deep knowledge that I have. It's just that I've been doing this longer than the average person, and I can show you guys some of the things that I've learned over time and some of the pitfalls. Right? That's the goal of this, is to get you guys into doing this stuff, get you guys into moving this stuff professionally, and all that good stuff. So, anyways. I'm going kind of far afield with this and showing you guys that all this to say, right? Let me clear the screen up real quick. If you do this, right? Let's say I did this command, SSH node 01 uptime, and it gives me the uptime back. Okay, good. I would never add a -v and try to troubleshoot it, because I want you guys to think about this real quick. I use this example a lot, so some of you have heard me say this. But if I was like, okay, Xshunya, you're going to go get everybody here ice cream. And then I toss you the keys to my truck, right? And you go out and you start my truck and it just starts up. I would not expect you to get out of my truck, kick the tires, open up the hood and go, yeah, it looks like the engine is engineering, and then go and check to make sure that the tailgate works. And, I wouldn't expect you to do that. It would be like, the truck started, let's go, right? And that's kind of how a lot of admin and engineering is. If things work, that's all we need to know. The thing worked. Who cares? Whoops. But if the thing doesn't work, then we're going to dig in. Then we're going to go start to peel back the pieces and see, well, oh yeah, the engine's not engineering. It looks like the electrical components are shooting sparks everywhere. Well, that's terrible. I don't know what that means, but that's probably not good. Or it looks like there's no gas in it, right? That kind of stuff. So, all that to say, we dig in as far as we need to and all that kind of stuff. But there's a lot of stuff. Now, we're only getting debug 1 right here. But if I hit this button, I will see even more information, and I will get deeper debug information about how the channel's connection happened. I will start to see more information. And then if I do another V, I will get even deeper debug information about how the client was actually sending information and the sockets and all that kind of stuff. So there are 3 levels of debug that we may use inside of our clients to see if things work. And I show you all that just to say, if you do a normal connection and it works, you may never have to do this in your entire career. You may never, as an admin, have to dig in on how SSH is or isn't connecting. But if you understand, right, if you start it out, you come over here and you say, well, at the very beginning, and by the way, this happens. This happens sometimes. You can't connect, and this breaks right here. You don't have a name resolution. Well, you wouldn't spend the next 4 hours if you had no name resolution right here between the node name and the IP address that it wants to connect to. You wouldn't spend the next 4 hours looking up SSH crap on Stack Overflow and asking AI and that kind of stuff in Google about that. What you would do is you would say, wait a second. Something's broken. Something's broken before this. The DNS part of it's broken. Does that kind of make sense? We could step back a little bit and figure out there's where the process broke. But for that to work, we need to understand how to go look at the process. So anyways, there's all that. What additional information was shown with the -VVV option? It dug in a little deeper and it gave us actual debug level 3 of what was going on with the session. And sometimes if you were going to have a real SSH connection problem. By the way, there's third parties that write SSH protocols for us, SSH connections and clients and stuff. There's a program that we just stopped using over at NOAA called Tectia. Tectia is a big SSH client and SSH daemon creator. It works with common access cards and like YubiKeys and stuff like that. But you know, sometimes they don't fit all your mission purpose anymore, so you move away from them. Well, you look over here and you say, well, if something was broken in their client, I might have to grab all this information to show to them. Silas Rogers said, can you teach me how to do SQL injection? Silas, this probably isn't the best place for that. We sometimes talk about that down in our Discord and stuff. I'm more of a guy who, I guess you would say, I do a lot more protection against that kind of stuff. Like I've done a fair amount of protection against that with web application firewalls and, you know, TLS terminations internal and that kind of stuff. But yeah, I don't do a whole lot of SQL. I'm not really one of the, I guess you would call me, like I'm not exactly one of the red team. Yeah. I've been a red team lead before for a very large Fortune 100 company, but that's not what I do professionally anymore, really. I'm just a Linux engineer, build platforms out. I do a lot more of the blue teaming stuff for sure. If that would be a very good app way to put it. So we look at the SSH connection over to node 01, and we note that the keys are being used and no password was asked to connect, and we'll talk about that here in a little bit. So we are connecting over to node 01 every time we do this, but we're not seeing a password. And the reason is because we have a key that's being accepted up here, and the key is being passed to the system. So let's look at this a little more. We are now asked to push a message of the day message onto a server. So node 01, we want to have a message of the day, a banner MOTD as we call them. So that's what that is. MOTD is the message of the day. And we know that the server has a correct etc cron tab, and we want to use that on other systems. So we're doing two things. We're going to push a file over, and then we're going to pull a file back. So SCP is always from to on the command line. So the syntax is SCP source target to destination target. So where are we getting the information from and where are we sending it to? So we've got an MOTD over here. If we if we cat etc MOTD, it doesn't look like we have one. Oh, sorry, cat root MOTD. We have an MOTD on the system. We already have it sitting here. So we're going to push that over. So we're going to say SCP root MOTD, and we're going to push it to node 01 in etc MOTD, message of the day. I gotta do the whole command like it's not stupid. That's how you push it. And then that'll copy it over. And now if I SSH to node 01, I should see the banner message of the day presented to me. So that's actually really cool. Right? That's cool, but that's also super functional. A lot of times we'll leave message of the days up so that maybe if there's maintenance that's coming, you'll find that, and this is an engineer and a scientific researcher thing, people will not read their emails, especially if you're getting 400 emails a day. I mean, we call that corporate spam, right? So one of the things that we know in like the Linux Unix world is if somebody's logging into our systems, though, they will read the banner message of the day because it's going to pop up right in their face. So this just says dev to let them know that they're in a dev environment. But maybe I also have different messages that say, and there will be maintenance from July 4th through July 7th this year. This server will not be available. And then we can do other things. So if I put the system into like a maintenance mode like that, I will typically do something else like what we call touch etc no login. And if you touch /etc/no login, any user that's non-root will not be able to log in. SSH will automatically, well, the SSHD daemon will automatically stop them from being able to connect, right? So there's that. So anyway, so we do that, right? And we come over here and then we can now pull the cron tab. So we want to get the cron tab from node 01. So we SSH node 01 // etc cron tab. And we're going to pull it back to temp node 01 .cron tab, let's say. And that will pull it, SSH node 01. Oh, because I'm on node 01. Let's go back over here. Sorry, and it's SCP. I don't know what's wrong with me. Node 01, etc cron tab. And then cron tab, and we're going to pull it back to temp node 01 dot cron tab, right? We also have the command down there, but that'll SCP it back over for us, right? So then we can, by the way, we can look at this a little bit. We can checksum the root message of the day. And then whatever we pushed over there, we can also SSH to node 01 and say, go ahead and do a checksum. CK sum is how it actually is. That's the MOTD. And what I would expect to see right here is this number should be exactly the same as it is over on the other system. And the reason is because nothing changed in transport. Nothing shifted around. No bits fell over. Everything's the same. Hey, Monkey Man, how's it going? Yeah, it is the 4th of July. Colchis, it is... yeah, one for one. We want to make sure the same thing is the same on either side, right? I show you guys checksum, but there's also SHA-1 summing. And let's look at this real quick. We're using a very small system, so we can get away with, we'll just change it here, SHA-1 sum, etc MOTD over here. And it's the same. But as you get to larger and larger, so the thing about a hash, no matter how large of an input you give to a hash algorithm, you will always get the same size output. So this file that's basically, I mean, that's like a few bytes right there. That's like nothing. But that file, I will still get a 32-bit, I think it's 32 bits in this. It's not bits, but it's 32 characters, right? Something like that. I'll always get the same length out no matter what. Now, I can also push ISOs through that. Like, those are ISOs, like whole files and checksums to make sure that things have not changed in transmit, right? And that's the thing that we can kind of learn and understand. But what I'm showing you guys here is we need to understand how to push. In this case, we pushed over our message of the day. And then we also need to know how to pull back a file from a remote node. And the reason that's so important, guys, is because you're going to do work on systems, or you're going to, as we said, SSH to node 01, and you're going to maybe VI etc cron tab and make this exactly like you want for the whole cluster. And then you're going to want to take that and you're going to want to push it to all the nodes in the cluster. So you might pull it back to your central jump box and then be able to push it everywhere, because maybe only your central jump box has all the keys. Or maybe you use a tool called like PDish or something like that, and you want to be able to see it. So my point in showing you guys all that, and I also was talking about this earlier before people showed up, where maybe you're on a Mac or maybe you're on a Windows machine. You do not know what productivity tool your company is going to give you. You'll get hired as a Linux or a Unix or a security engineer, and you don't know what their standard is for desktop security around there. Very few companies, again, are going to support Linux desktop. Very, very few companies. And if they are, they're probably very lax on their overall security posture. In fact, the only company I've worked for that allowed, or I didn't work for them, but the only company I've worked with, well, let me put it this way. I was allowed at like Best Western to use any desktop I wanted, so I did use Linux over there. But the only company I've worked with where like traditionally all their engineers would come in on Fedora was Red Hat. When I worked with Red Hat heavily, every one of their engineers would come in on a Fedora distro of some type. And that's fine, right? But even then, it's like you have to know how to move and push the files around in your system, right? It's a critical skill as an admin to be able to push and pull files around, right? So we did that. We checked some of the messages of the day. We copied it from here to there. We went and looked. Whoops. We looked at it and saw that there was the system. And then we pulled back the cron tab to here. And then we validated that the checksum was exactly the same between the two. Nothing changed in transmit. Our tools have worked the way we expect them to, right? So we hit check. It says, look at you learning Linux. This may seem like an overly simple skill, and it may seem like something like, oh man, like Scott, I picked that up in a day. You probably could. I think most people can. But you do have to spend time with this and understand Where are the system files? Okay, they download it. So some dev team downloaded something that they need staged and pushed everywhere in the company. I can either go re-download it from the vendor, which may take hours or days, right? Or, I mean, depending on what our pipe looks like, or they already have it downloaded and staged somewhere, and I can pull it back and then use that to push everywhere. This also comes into, there's an interesting concept here of if there's shared storage, do we put it out on like an NFS share, or is our NFS too slow for this? Because sometimes NFS has some slowness, especially if there's a lot of people pulling and pushing. So maybe that's not the best way to deploy big software. NFS is tremendously useful for changing configurations, though, because a configuration file is nothing. An NFS link can move all the configuration files you have in a few seconds between systems. So it's tremendously useful for that, especially as on mount and then configuration as the system first comes up. That's really powerful, right? So anyways, pushing and pulling files around is, I don't want to call it like an underrated skill, but it is absolutely an admin skill. Absolutely an admin, and then heavily as you get over into engineering, it's a heavily that part of the skill too as well. And then you guys might have noticed I left Ranger Cam up. Ranger left us yesterday. We took him down at around 3 p.m., me and the wife, and he was in a lot of pain, guys, so we kind of let that be done so he doesn't have to. All right, so let's go look at some screen commands. These ones get a little weird. Screen commands get a little weird only because some people are ardent supporters of screen and some people are ardent supporters of tmux. Let me tell you that tmux kind of won. Screen isn't really being supported much anymore, so screen doesn't even get mentioned in stigs. But screen also, tmux also doesn't get reported in stigs as much anymore because tmux isn't a requirement. There used to be requirements all over these stig viewers of I could have pulled up tmux right here, and I don't think it's even there anymore. Let me remove all filters and type in tmux. Yeah, see, it's not even there. But in the older stigs from last year, you had tmux all over them for timeout and session control and all that kind of stuff. Yeah. Yeah, Raymond, yeah. It's yeah, a little hard. So, let's go look at pushing around the screen sessions and what I use screen for. Whatever you guys use, like whatever you use to have persistent, I don't care what you use, but you should have some way to stay persistent in an environment. And what do I mean by that? Let me show you an example in my home lab real quick. I am jumped into my P01 Jump 01 box. Jump box is getting decommissioned. Hold on. Jump box is getting decommissioned, and P01 Jump 02 is coming in his place soon. So this box is not going to be the primary box here probably in the next few weeks because he's sent to S7 and he doesn't have support anymore. But what I want to show you guys is I'm on a non-Linux box, right? I'm on a Windows box. But my connection in right here, I just deleted it. I just got rid of my connection. I use PuTTY, right? I'll use any terminal tool, but I'm using PuTTY here. And I'm going to go jump back into that P01 Jump 01 box, right? So here's my brand new connection back over there. And most of you know when you make a brand new connection, when you've deleted your old connection, everything that was a child process of your bash shells are all gone, right? So now I'm here. Whoops, I think I just did the password wrong. Now everything's gone, right? I don't have any of that cool stuff. But when I have a persistent no-hup environment, like screen, I've got this detached screen session right here. And screen is kind of behaving like a plane, right? It's kind of becoming like a flat plane that I can connect into. Anybody here ever seen that movie Life? Absolutely just atrocious movie, but it's them up in the spaceship and they've got this little creature that's in this kind of like a air-gapped environment that's all, and then they're reaching in with the little gloves. That's kind of how I think of like screen. I've got these gloves. I can disconnect and I could go somewhere else and I could reconnect. Well, unless I'm dumb and I'm dealing with this life organism that's just going to kill all of us, right? But Raymond, yeah, I'm going to switch over to Rocky 9 for the new jump box. Yeah. It's going to be Rocky 9. In fact, I have it built out. He's built out. I just haven't moved the IP addresses over. Where's that? He is. Here's Jump 02. Yeah. We probably need to get in there and clean them up a little bit and make sure they're patched up and set up all the ways. So I do have work to do in the lab. I just haven't been doing it. But I want to show you guys. I can say screen-R, and then I can connect to the exact one. But since he's the only one, I could just connect to him. And now I will be back in exactly that same window we were just in, doing exactly all the same things, right, that we were just doing. I have all the same windows and all the same things that we were just messing with, and the no-hup environment meant that as I lost my connection to the server, I didn't lose my connection, like my web of all the things I was doing out from my jump host. Super powerful, super useful as an admin to be able to, I mean, because back before I used that, I used to have to do everything at work, close everything out, be all done, and then go home, and then if I needed to connect back in, I needed to reopen everything up. Now, if I were to take my home machine here in a couple of weeks and go down to Mexico like me and the wife are, I can jump right back in from remote and be at this same exact window right here. I've shown this to you guys before, even last year when we were down there. I can be in this same exact window doing these same exact things, but from a different country, from hundreds of miles away. I don't know, we might even be 1,000 miles away at that point. But the point is, you can do all that stuff. So you're a new systems engineer for a small Linux-based tech company. The other engineer set you up with a tool called Screen and gave you a basic configuration file for it. Inspect the configuration and see what advantages you can find for the tool in your daily systems activities. So our file is right here, Screen RC. And if we go look at it, it's got some basic little configurations. I always give credit to the original author, Christian Willis, right? And we can allow bold colors, and there's some term cap info and just a bunch of things that are set. These are all defaults for the most part. Some of the defaults have been commented out as well. But this is here. We could define, do we need more scroll back than 30,000 lines? Maybe we do, right? And then just some information here about what's going on in the system, right? And I just always liked this. I always thought that this was a good little set of information for us to have. So I like this one. And we're going to go ahead and then start Screen, and we're going to mess with it a little bit as a tool, right? So we cat out the file and look at it, good. And then we're going to start Screen. So Screen says it's this version, 4.0.9, 4.09.01, right? And it's been updated in the last couple years, but they're not really supporting it much anymore. So it's kind of a bit older, but look, it's been around. Probably been around longer than some of you have been around, right? So now that we've got a screen session started, Two Boblik said, is it okay to learn Linux with WSL on my Windows machine? I think that's 100% fine. Yeah. So the question was, is it okay to learn Linux on WSL? Yes. If you are doing zero Linux today, right? If you're not even in a command prompt. By the way, I would tell you guys, come in here and do Killer Coda. They're free, right? I'm linking it to you guys. But if you said, hey, Scott, I'm not doing any Linux today, can I do Windows, can I do Linux on WSL and do some things? And I'd say, okay, well, sure. Do something. Get your hands on Linux every day. But then once you start to, maybe you've been doing Linux for a year or something like that, and you're like, no, now I want to go get a job, I would tell you to start tuning it down towards Rocky or Ubuntu or the types of Linux that are used out in the enterprise. Xshunya, that is in a different language, so I cannot read whatever that is. I think you either turned your filter off or I can't read that. That's in, I don't even know what language that is. It doesn't look like Chinese. That's over on the YouTube side. But I can't read that Xshunya. So now, once we're in here, we can use Control-A plus S. So I'm going to hit Control-A and then Shift-S. And it's going to split my screen horizontally, right? So now across the horizontal, boom, here and here. And then I can jump between it with Control-A and the Tab key. So Control-A, Tab. Whoops. My system just busted. Control-A, Tab. Okay, and now I can hit Enter down here. And maybe down here I need to hit Control AC, and now I've got a new session. And maybe now I'm in the other session. And then now I'm over here, and then I hit Control A tab, and I'm back up here. And then it tells us to rename the window that we're in. So up in this window, we're going to hit Control A and Shift A, and we're going to call this window top, maybe, just for fun. And then I'm going to hit Control A tab to go down here. I'll hit Control A, Shift A, and I'm going to say maybe window bottom, right, just for fun. And then now I can hit Control A and switch between window top and window bottom. Do you guys see that? In the bottom part of the thing here. So we can do all of these things that are kind of shown here, right? And maybe down here I say while true, do, maybe uptime, sleep to, done. So down here it starts doing that. Then I hit Control A tab up here. I hit Control A over here, and then maybe on this one I say while true, do date, free-m, sleep to, done. And then now this one is running some other thing, and maybe I make these a little smaller so they're easier to see. And then now, maybe tiny little bit smaller. Right, and that's a little easier to read. And then now my windows are doing other things, and I can hit that to go to, so they're both on the same screen session here, the same window. And then I jump back over to maybe window bottom, and now I'm doing something else. So I can hit Control A and tab to jump between them. So Control A tab to jump between them. And then I can use Control A and Control N or Control P to jump left and right, if you want to think of it like that, across them. Akshunya, I will definitely show when I set up P01, or so P02. I will 100% show that as well. Yes. I just haven't, I haven't decided. Like, I was just going to do like a little short stream today and kind of hang out with people. And, you know, it's 4th of July, so hang out a little bit. The wife's going to visit one of her friends. She cut my hair. My hair looks real nice. I'll pop on stream here a little later maybe, but we're just kind of hanging out now, working through stuff. And hanging out. So, yeah, so we do that and we hit check. And then it says detach from the screen session and verify it's still there. So now we come over here and we hit Control A, Shift D, and we are detached. Whoops. I need to make sure I'm in there. Control A, Shift D. Yeah, there we go. All right, so now I'm detached, but if I do a screen -ls, I should still see that screen running. Detaching from a screen session does not stop it from doing what it was doing in the background, guys. It is still back there being a no-hup environment. No-hup means it does not die, and that's N-O-H-U-P. That's what a no-hup environment is. Not a no-hop, it's a no-H-U-P, hup. Hup. Oh, whatever. I finally got it. All right. Now I can do a screen -R and reconnect. And now I'm back on here. And, I can't use Control N because that's going to make a new. So you can't use Control N in this environment. But you can use Control A. And you should be able to Control P as well, I think. Yeah, see, this one also stopped because of what I was doing. But there we go. We see both of those environments still there. Now I can kill each window, Control A and Shift K. So Control A, Shift K. And it says, do you want to kill it? Control A, Shift K. Yes. And you got to use Shift because it's got to be a capital K, you know. And then now we're going to start screen again. So we'll say screen -ls. And we see no screens running. So there's nothing. Yep, no hang-up signal. Absolutely. Oh yeah, Akshunya, I did actually start that process a few weeks ago, so I will definitely talk through it when I do it, though, yes. And I'll show kind of how I hardened it up and all that stuff for sure. I think I even, yeah, I can show that for sure, Akshunya. Maybe I'll start dropping the topics in the Discord as I do that too. Maybe that'll be useful for people to find stuff later. For you guys that don't know, we do have a Discord. Discord is free. And what I was talking about is a lot of times it'll tell you guys when I'm streaming. And then maybe I can put like, because we have what we're generally doing for the day, but then we also, you know, have other stuff that we go and talk about or work on. So maybe I'll start adding some of that stuff in as well. All right, so now I want to do screen, but as I start the screen, I also want to have a screen log. And the log is important because maybe I want to capture all the raw things that I do so that if I miss anything, normally I throw stuff, you guys see me throw stuff out to like my notepad here. And then with my notepad, I can capture things and do whatever. But maybe sometimes I also want to have my system just gathering all the raw notes and all the raw output of everything I do. And this is what I call like my first level of note taking. This is my first level of note taking. I have 3 levels of note taking, guys, if you guys don't know. My first level of note taking is right here in the terminal. I'm going to let this thing log to root screenlog.log. So now, if I were to come, let me just jump over into like another terminal here real quick. And on this terminal, if I was to do a tail-f on root screenlog.log, right? And then I come over here and I start a, maybe I do that same thing, while true, do date, uptime, sleep to done, right? Now this is going to give me a date and an uptime. But over here, I'm watching a tail of that happen. So this is what's being recorded right here. If I'm just sitting here watching this, this is what's being recorded right here on that other side of the system, right? From that screen session. So the screen session here is doing all the things it's doing. And then let's say I were to close out this screen session, or, you know, forget what I'm doing and go to lunch, or somebody pulls me away to some emergency. And I jump back over here, and this thing is now keeping track of everything. So if I have to pull like this part out for my notes for some reason, you know, some anomaly in the time or the way that the system's behaving, I could do that. I have that recorded in the system. Then my second level of notes, because some of you are like, wait a minute, you just said your first level of notes. What is your second level of notes? My second level of notes is when I'm done doing whatever work it is to build something, right? I'm pulling stuff out in real time. And then a lot of times I'll get this from like my history, and I'll be like, oh yeah, I did this command, and then I did that command. Oh, that's pretty good. Yep. I need all those things. And I'll go take those and I'll throw them over here. And this is kind of like, this is slightly less, whoops. This is slightly less than my raw notes. This is more of like my, you know, a little more finished in, a little more than like just a rough draft. And then when I'm ready, and this is all cleaned up and ready to go out, it goes into Markdown or Google Docs or, you know, spreadsheet, whatever I'm using to report it up. And sometimes we use tools called like Confluence and stuff. Confluence is a nice note-taking tool for like how you built stuff and how you design stuff for a company or whatever. So they got some really kind of useful tools inside of Confluence, and I'll use that to like report stuff up to customers and stuff. In fact, I got to do some work with that later this weekend. For a customer that I'm working on. All right. So, anyways, those are kind of like my levels of note taking. It's very raw over here, as the system's doing whatever the system's doing, and then over here I'll pull out kind of like my notes and my shorthand, and then sometimes I'll go pull things and be like, oh yeah, this was really useful to show somebody, and then I'll add it in. You know, it'll be like part of this here. Oh, geez, it'll be part of this over here, and then I'll clean it all up and stuff. And this still doesn't get shown to anybody. This right here, you still don't see this professionally from me. But then when I have it all done here, and I'm like, okay, yeah, now this starts to look nice, then I feed that out to the final product, if that kind of makes sense. It's almost like a buffered way of doing notes that I like doing. And it gives me a buffer here where I have everything. I have a filter down to like only things that I think are important, and then all the way to, you know, whatever our completed thing is. And some of you guys that have been around long enough to kind of watch me do this stuff, you're like, okay, yeah, this is what this guy does, you know. Oh, looks like the wife's leaving. That was the garage door open. Well, there was the light through the garage door coming in, but... All right. So anyways, so we come over here, we start our screen session, we run maybe something over here. And then I should be able to go over here and watch that happen if I go look at my... Oh, yeah, we're actually still tailing that. So this is still getting that output over here from what's being written to that, right? We could watch that all happen and then go over here and it would still be in that log file. Now, I'm going to detach from the screen. Control A, Shift D. Oops. Maybe I'm not. Whoops. Maybe I'm not in there. Maybe I'm not in that whole. Let me get this back over here. Yeah, I don't know why that won't detach. Oh, it's because I'm not holding it. I'm being dumb. Oh, because I'm on the wrong damn side. That'll do it. There we go. Jeez, it took me like 30 fucking tries to disconnect. Anyways, there's our disconnect. It's because at first I was in the wrong tab, right? I'm not normally tabbed like this inside of a browser, so that's not my normal workflow. But anyways, over here I could check that, and I would see everything that we've done inside of that terminal since the start of that screen session, which I'm telling you guys, that's super useful. That's super powerful for you to kind of understand that you can be connected to a system, disconnect, go home, reconnect to that persistent node, or I call them jump boxes, jump box inside of an environment, do whatever you needed to from home, go, be off for the day, have your weekend, whatever, come back on Monday morning, reconnect into that cluster, and then jump right back into whatever work you were doing. Super, super useful, especially in big storage area networking where you have to like touch a device and then let it just run or recalibrate or do whatever with its disks for hours and hours, maybe even days. That's gonna be super, super useful. So, all right. Anyways, that was Lab 6. We have a Lab 6.5 for TMUX, but I'm gonna let you guys play with that on your own time. We'll go over to do the DNS lab. So we'll do DNS next. So if anybody wants to follow along, there's our DNS lab. There it is on both sides. We're going to mess around a little bit with the things that I think that you need to know about DNS as an admin, right? Admin, and then later on into engineering, right? So I'm going to make this a little bigger so you guys can read it. And it says your team is going to be doing some DNS work and you have to figure out how to use the tools in your Linux system. Maybe you've never messed with DNS. Maybe you haven't ever seen name resolution happen. We're going to use host, dig, and NSLOOKUP to figure out what types of information they show us. And then we're going to look in the contents of the etcresolve.conf file. That's etcresolv.conf. And then we're going to do a trace route to some of these different open DNS relays that exist out there for us to go check stuff with, right? So here's our solution. It says use the host program, right? Use host to go hit Google. So we do host to Google, and our system did a DNS lookup and got information that Google had an IPv4 address of 142 dot something, and it has an IPv6 address of 2607 colon something, right? Some long number. Important to note, IPv4 is always 32 bits represented in dotted decimal, and IPv6 is always 128 bits represented in hexadecimal, right? That's important to note because this is hexadecimal, it does use the numbers A through F. And you say, wait a minute, you just called them numbers. They are numbers when they're being used in hexadecimal. A, B, C, D, E, F are numbers in the hexadecimal numbering system, so they do not represent letters at that point, right? Which is important to note. It may help you later on in your career. So how does a record... So now we did host, and host just told us some information, but it didn't tell us what the records were or anything like that. So if we go look a little deeper with like dig will give us similar information, 142, 251, 140, 164, same. But it tells us that it got a response via what's called an A record. A records are the DNS name resolution between the human readable name, DNS name, and the IP address that exists at layer 3, right, of our OSI model. So the A record maps between those two for IPv4. The quad A record, which is 4 A's, it's called the quad A record, that's going to map between Google here and our IPv6 address. And we can force dig. I don't really make you guys do this, but you should be able to tell dig, I want the 6, I think it's 6 like this. And that should give us, if we had the capability, that should give us the, no? Should give us that. Maybe I have that wrong. I thought it was dash. Yeah, because normally you can just do a shorthand -6 like that. Maybe -T6 will do it. But normally I thought just it would be 6. No, yeah, see, I ignored the -T. Normally you just put a -6 on it and it'll do it, but maybe there's some reason. It says its connections refused. There may not be the ability to communicate out. There's a whole bunch of reasons, I guess, that DNS could break, but we don't have control over this network, so we can't go look at it. But we were trying to force it to use IPv6, so that's important to note. But dig by itself works and gives us an A record response, so that's cool. It also tells us the server it used. It used 8.8.8.8, so we know we're not using local. We know that we're not using local name resolution. We're using DNS resolution outside of our inside DNS resolution, and this may be important for our troubleshooting. Like, I'm trying to hit some IP address, and I'm trying to use a short name internally, but I'm using an external resolver because I don't have anything internally configured. Well, of course you're not going to find an internal name out on the web. Why would the web know? Like, if you had, I think it would be weird if you could go out on the web and not only see like a picture of your house, but also it had mapped like where all your kids' rooms are. That would be super weird to me. Why the hell should anybody outside know that kind of stuff? Well, it's the same kind of idea here. If we're resolving an outside address, or we're using an outside resolver, how could it know if we had something internal, right? Okay. What prompts you wonder what? Okay, so you want to see where our system's configured from, and this is our etsyresolve.conf. There's lots of other information in here that you might go read about and look at, but here's where our system is going to look. It's going to look in 8.8.8.8 if it can. Then it's going to use 1.1.1.1. And it's going to use that for any name search, right? You can also search specific domain names and queries and stuff like that. You can shorten down those answers to here. And then we can also use traceroute. Traceroute's a really awesome tool that doesn't always work great for us because traceroute uses ICMP under the hood, Internet Control Messaging Protocol. And one thing I sometimes show people is people just think of ICMP as ping, but there are so many things that ICMP can do besides just ping. Ping is 2 parts. It is echo request and echo reply, right? But there's also, here's echo reply and then echo request requests it. But look at all these other, here's your destination unreachable codes. Here are your redirects, if there's any redirects. Here's, this is 8 is echo request, so when we're sending, echo request and echo reply are what most people think of. But there's a tremendous amount of other things that can be shared all throughout it. Now, that being said, most of the time, all of these destination unreachables are turned off from a router. And does anybody know why your routers, especially externally facing routers, have all of this turned off on their interfaces? Why would a system not want to tell you if a destination network's unknown, or if a host is unknown, or if just the port was unreachable, or if the destination network was unreachable for some reason? Why might somebody not want to send that back out of their system? What would that be useful for? It's Intel, right? Yeah, it's free mapping. It's additional information that they don't need, right? Yeah, you don't need that kind of information. All right. So anyways, we can do a traceroute, but I often tell you guys with traceroute, you'll find that you'll just get the dashes as timeouts occur because devices are not going to respond. Devices on the internet will often not respond. they've been configured to not give a full mapping of what's going on out in the world and out in the network. And you might do a couple of trace routes and then say, the question may be, are we taking the same route every time, or is our system going to take different routes? And this is something that you can then go figure out and look at and go, it does appear to have taken the same route both times, and both times it didn't tell me this number 7, because that's probably some device out in the internet and inner world, all that stuff that, yeah, we don't want people to see what's going on inside of our actual system, right? So, yeah, Ramon, that's exactly right. Prevent reconnaissance on the network. Why would I tell you anything, right? It's like if you guys have ever watched, like, look at some old spy movie and the person's like, oh yeah, we're here to get a table, and the bouncer's standing there with a list, and he's like, well, just let me see the list. Oh, that's me right there, Dr. Caravel or whatever. And you're like, oh yeah. Oh, well, obviously, doctor, come along. And it's like, why the fuck did you show him the list, right? But, of course, for the plot to move forward, something stupid like that had to happen. But from a security standpoint, no, you give me the information, I'll take it back and look at it and tell you and then come forward. That's exactly how the PAM modules work, by the way. The pluggable authentication modules don't tell you nothing except if you passed or failed whatever test you gave. So you ask, hey, can you validate this user's, here's a hash of the password that the user gave me. Can you validate it? And PAM goes and looks and sees if it's right and then tells you if it is or not. It doesn't even tell you if the user existed. If you tell it to go test for a user, it'll either just come back with yes or no, right? And you can test that, and you can play with PAM and stuff like that, which we do a little bit in the security course. Not as much as we might have liked if we were going to dig in hardcore on it. But my point is, ICMP has a lot of stuff for you to read about besides just the ping portion of it, right? The packet internetworking groper portion of it. So, Chris, I'm saying that you should not necessarily respond with any ICMP replies out. No. Yeah, like if you, I wouldn't allow somebody like to ping one of my web servers directly. No. They can, if they can see, so if there's a DNS resolve to like an IP address or something like mine, this is exactly, by the way, why reverse load balancers are so useful. Reverse load balancers stand at the front of your system and take the connection. Sometimes they even terminate the TLS for the whole environment. And then they take that message and give it to somebody on the back end themselves. But they never let you do it. And I always use this very visceral one. This is going to be very visceral for you parents, but it's true. If I came to your house and I'm like, I've got a letter for your kid, you may take that letter. Some of you might take that letter. But I tell you right now, if I said I'll just deliver it to their bedroom, I'm going to tell you right now, you'd be like, the fuck you are? Get the fuck out of here. And that's exactly how it is with systems. Like, I'm not going to let you map my internal network. I'm not going to tell you nothing about what's going on back there. Hell no, right? I'll take it to the system, right? And I say that like as a very visceral thing because I think any parent here is like, you might get punched in the mouth for trying to do that, right? But that's exactly what they're trying to do with your network. They're trying to figure out stuff back there that they don't need to know, right? So anyways, yeah, I do, for the most part, you don't want ICMP traversing your network. Now, internally, it's fine, but not in zero trust. In zero trust, you shouldn't be responding to it. Devices can either talk to the things they know about or they can go kick rocks. And if your whole network doesn't work, zero trust is fine with that. Yeah, Ramon, you get it? Yeah, hell no, you're not going in there. Yeah, that's super weird, right? Like, but I use it as an example to show you guys, like, this is how security, I mean, you should think of your network with the same zealousness that you do to protect other things, right? So anyways, now that you've looked around with the tools you have, let's figure out the order your system looks resources up in. Now, I use this to show people, if you've never looked at the nsswitch.conf file, your system looks things up in a particular order. So just bear with me here, follow along. I really should draw this out, but we're going to just do it in our heads, and I think we'll understand it. So we're going to make sure that our system looks at DNS, and we're going to add a record for Google and Yahoo. So we're going to break the system here. So we're going to inspect it first to make sure it works. We're going to break it, and then we're going to validate that it broke, okay? That's kind of the flow of this lab. So we cat etc nsswitch.conf, and we go and we look at this file. And down here we see that for hosts, our system looks at local files first, and then it goes out to DNS if it doesn't find something. And I say, okay, that's interesting. Let's go and curl Google and there's a Google page, lots of Google in. And then let's see an output for Google, okay? And then we can look up the host for Yahoo, and here's a Yahoo address, 169.140 or 69.147.92.112. And then we can go add that host, or this is a different host here, the 74.6 or whatever. And let's just throw this one in there. That's fine. That's not the exact one we found, but it's the same thing. And then now if we curl Google, we get this Yahoo system. We get this Yahoo because that's a Yahoo IP address that we used, that one that we threw in there, in our Etsy host file. We basically just broke our Etsy host file by adding a Yahoo IP address in for Google. Now you could use this one as well, the one that you actually found, but this is fine. And then now if we vi our etsynswitch.conf and we switch those, so now I'm just going to go right here. I'm going to say YYP, and I'm going to comment out my original, and I'm going to flip these. Right? So I flipped hosts real quick. Now I do my curl of Google, and I'm back to seeing Google normally, but why? Because now we're looking at DNS before we use our local files. And there are reasons that you might want to do this. If you need to make a visceral video to point search Tina plotted online after confronting with aggravated neighbor, a current affair on YouTube. That's funny. That's not the one where he chokes the guy out, is it? Too big? I've seen so many of those. I've been seeing videos like that for a long time. Oh, he punches him out? Well, that's funny too. But I've seen a lot of dumb videos like that over my time. All right, so look at you learning Linux. So the point is, we can change the behavior of our system if we understand where it happens. And in this case, it's at CNS switch. And then we may want to trust our local host file, or we may want to trust DNS. By default, your Linux box is going to trust files before it trusts DNS. And I'm going to tell you, in normal operation, that's probably the right behavior. Also, I can tell you in the corporate world, on the Linux side, you will probably not control DNS within your company. Your company will probably have DNS tied with Active Directory. So your Windows team, right? Or maybe it's your own team. Maybe you guys are platform engineers or something and you're all mixed together. But my point is, the Windows team controls Active Directory and DNS, so you may not know when that's down. Maybe there's a power outage, maybe there's something going on in your environment, and you may want to make sure that there's enough files and enough known flat files, because a lot of people are like, oh, I'll never put anything in a flat file. I don't know, I think there's good reason for flat files. A lot of cluster managers, all the big cluster managers run flat files. What do I mean by that? Like Werewolf? Werewolf's a huge one. Now, if we go over here, where are we at? So Werewolf, and then we cat Etsy, whoops, hosts. He's got a flat file with all of his nodes in there, and those configurations are persistent like that. Okay, so that was Unit 7 lab, or Lab 7. Let's keep scrolling down, keep scrolling through these, and next one, right? For this is, again, we're just generically going through things that I think you need to know to get into Linux as an admin. Things that I think that will be valuable for you to understand at a high level from maybe watching this and playing with these. And then you can go dig in more and understand at a, more, maybe some of these you have to go practice with. Maybe some of these you got to go find some scenarios where you maybe break and fix things to be able to understand them better. But we're going to do some kind of variables and logic now. To Bolblick, he said, are there any good resources for career progression paths like in IT? Like, for example, ending up in Linux systems engineer, would admin be before that? And then help desk tier 3 going back? Yeah, I think help desk would be going backwards from Linux admin. I have a drawing that I sometimes use This is not going to be probably exactly what you're looking for, but let me get rid of this, and then let me open up. Let me see if I have a drawing on. I think it's this drawing that I normally show. This is Linux sysadmin stuff. This is like things that I think you need to focus on and learn for like a Linux sysadmin role. Hold on. And one of the things I show you guys, yeah, this was titled Getting into the Linux Engineering Field. And this is over here, kind of the way that I think that it's going to happen for most of you. Well, for the people that it happens for, people that get into the field. Hold on, let me get this back up here. Let me pull. I don't know why I keep putting that damn thing in front of everything. But let's go here. And this is the PPDIOO methodology. This comes from Cisco. And they say that you prepare, plan, design, implement, operate, and optimize the system, right? When you're building a network, when you're deploying something, whatever you're doing. And what I would tell you is you're probably, as a Linux systems admin or systems administrator, you're probably going to be starting heavily over on the left side. Maybe 100% of your job time, 100% of when you get in on a Linux admin role, is you're going to get in on like an operations team. So you're down there under operate. And you're going to be doing the function of KTLO, which is keep the lights on. KTLO is keep the lights on. So then what are you doing? So how are you getting onto a team? How are you working into a company that you've never worked for? Well, maybe you're in the network operations center. Maybe you're in a security operations center. Maybe you're on the help desk. Maybe you're schlepping computers around. Guys, when I got out of the Army, I moved computers for a school district. I had a CCNA already, but I went and I just needed a job. So I got a job as a Linux administrator, or as a LAN tech, local area network technician for a school district. And I just moved stuff around for them. And then after about a year of doing that, I moved up to a LAN 2, and that's where I was in charge of all like the wireless and all of the networking. I was in charge of the wireless and all of the firewalls for the whole school district, right? That's what I did. But then what I would tell you is, so you're operating the system, right? You're keeping the lights on, you're keeping stuff running. And then what I think you need to do from there, because again, we're wanting to get into engineering, right? You're going to, how are you optimizing it? How are you doing better? Hold on, guys. I'm going to grab water real quick. 1 second. I got water's up here. All right, so how are you doing this better, right? How are you optimizing the system? Are you building out monitors? Are you writing documentation, right? So how do you do this better? I'm going to say right here. Updating docs. Are you training others? Are you maybe writing brand new procedures? Are you monitoring correctly, right? Like, how are you optimizing the process of maintaining this system? These are like, this is where sysadmins live right here. This stuff right here. This is where you kind of live. Sysadmins start over here. And where we kind of want to get as engineers is over in the project work. We research new technologies, we plan them out, and we design them, and we implement them into an existing system, right? And by the way, sometimes engineers, so I would say like as an admin, like an admin might be, where's this at? Hold on. Why can't I see that? Oh, because the text is black. Okay. Need to go back, forward. Hold on. Edit. Redo. Alright, well, apparently I can't undo that shit that I just... Fucking annoying. Anyways, I would tell you as an admin, you're probably 100% over here, right? So this is your admin. over here 100%. And I would tell you that an engineer is probably 80% over here on project work. But guess what an engineer is still doing? They're still doing some of this stuff over here, especially if they didn't do a good job of writing up their documentation and stuff. An engineer still spends the rest of their time over here helping run things. So engineers never get completely away from that stuff, right? Hey, S. Willis, how's it going? And then Pythonic. Hopefully this stuff's useful to you over on the YouTube side. We're just walking through stuff that I think admins need to know. That's what we're working on. Is how people get into this. Mirage said, how do you use Excalidraw in VS Code? Yeah, you just come over, just go to VS Code, and you just go to extensions right here. You just download the extension for, there's just an extension for it. Guys, Excalidraw is open source, and they do have an extension for VS Code. Yeah. So here's a bunch of Excalidraw stuff that you guys need. Yeah, I think Excalidraw is great. I think it's a great tool. And then I have a bunch of stuff over here, like when we were talking about getting into the Linux engineering field, right? And Linux admin is kind of how you started out. I think you need to understand troubleshooting. We've talked about troubleshooting a lot in the time that we've been doing this, right? Troubleshooting is there. I think this is important. Also, to public, this is also up the Excalidraw. If you look for the .excalidraw extension inside of our Discord, I think you'll find, hold on, let's go look here. I think you'll find, I've posted a lot of these. So there's Linux Security Engineering. So you'll find a lot of different Excalidraws that people have posted. So feel free to use those as well. Anything in the Discord is free to use, guys. You don't have to just grab it off the screen while I'm talking here. We post most all this stuff up in the Discord. Understand how you troubleshoot, understand functional versus non-functional testing and how that relates to troubleshooting. Then we had questions that people had asked. This was from a long time ago, but like, what troubleshooting frameworks do you use? I use something like this. I always walk through something like this. How do you get hands-on skills? Well, you have to just baseline. What is baselining? Baselining is how the system operates in normal, whatever. Make the headers a bit bigger. It's easier for scanning. Like, give it a. Yeah. So, getting hands-on skills, getting a junior sysadmin role, what to document or otherwise do as a project. So we've worked on this extensively, right? Like I have whole courses that are free in our Discord for you guys to use. I have the 2 books right here that are free for you guys. Like this is a free book right here on Linux admin stuff. Goes over all this. And this is a free book right here that goes over security engineering stuff for Linux, right? So we have these books that the guys put together, which I think are awesome. And then we come back over here and, is there a structured guide to get into tech? Man, I wish, but there's too much stuff. There's too many paths that are going to get you there, I think. I think there's so many things that you can do. Hey, Schizophrenic, hopefully this stuff's useful to you. Yeah. I try to distill as much of this down as I can, but there's not any one path. I think the number one thing is just you guys got to keep working on it every day, right? You got to keep touching this stuff. You got to keep working on it. People were asking what type of jobs can you get as a Linux admin and engineer. I like to look on DICE, and then I'll show you guys like job skills. Like we walk through this pretty regularly here. We'll come over here and we'll look at like real engineering jobs, and then we'll walk through like these are actual jobs that people have asked for, and these are what I think that you should be doing to get ready for that type of work, right? We've walked through all these. These are all up in the notes section of the Discord, right? We talked about what's an automation mindset and being able to automate everything. Yeah, I think that's a main thing too big is people they'll get paralyzed. They get kind of worried about like, oh, I might break something. Guys, breaking something in a lab is the best time to break something because then you get to figure out how to work it. Alex over on YouTube said, when is the deadline for the sysadmin course? That's an excellent question. The sysadmin course right now, for people that are doing it with us, this course is in it'll be in unit 13 tomorrow. We're going to do system hardening tomorrow. I will be in Mexico for Ansible automation, so I might try to get somebody to run this one for me. And then after I get back from Mexico, we'll probably do troubleshooting. So that'll be that next weekend, and then we'll do the big incident response one. I think people have a lot of fun with incident response because we actually do it live and we break stuff. I have real broken environments, and you guys get to work together and shout out your questions and answers and try this stuff, right? Like try to fix this stuff together. And you guys will see what it's like to be in kind of the mayhem of everybody yelling and stuff like that. So anyways, Alex, I think the end of this course will be then like right at the beginning of August. I would say that's the beginning of August right there. Hold on, let me go look. Yeah, I would say by like August 8th we'll be done with the course. So, and then we decide. We're not doing this one again this year, I don't think. I think this one's done for the year because we've done 2 of them now. But we will probably do another security engineering course before the end of the year, and that's the one that builds all this stuff. So, good challenge for you guys as well. So, I thought the security engineering one went really well. I think most of the guys that did it got a lot out of it. That reminds me, I need to deploy a new version of our web page. Our web page is deployed. It's a Go container that Treasure maintains, and then we run it internal in our Prolog Kubernetes cluster, right? So this is highly available back behind our cluster. So I have that process all drawn out, but I could go deploy the new one right now. That seems like too much work. Let's just keep doing Linux stuff for now, and I'll do that later. It's the 4th of July. I'm not supposed to feel like I'm working too hard today, right? So, think developers are replaced by AI. Interesting, Schizo. Yeah, I think it's going to be an interesting trade. I think interesting things are happening in the industry. I don't know where all that stuff's going. I can tell you that understanding this stuff will still be of great benefit to people. This premium, is this for beginners friendly? I think that I think this Linux admin course is very beginners friendly. I wrote this for somebody who's maybe a hobbyist that likes to play with Linux and get into it. And we focus, all of these things here are focusing on what the jobs in the enterprise are. So I think this is beginner friendly as far as like maybe you already know you like tech. The security engineering one is this one is more challenging, and it is not entry-level Linux. This is not entry-level stuff. Like, there's no stopping to make sure that you've CD'd into the right directory. You have to know that stuff. You have to be able to PWD and tell where you're at in the system, right? But this is, like, I think this is more project as well, so there's, like, a lot of project stuff. But I think this one is still beginner-friendly. You just have to kind of be comfortable inside of a Linux box. So, but also, a lot of people don't realize, like, getting directly into security in the industry it's pretty difficult. You have to know a lot of stuff. You need to understand your Linux. You need to understand your likely Windows stuff. You definitely need to know your networking, right? Like, you don't just jump in. You have to understand different components of the system. So that's my thoughts on that anyways. But all right, let's keep going on our labs. We'll start with variables and condition logic here. So inside of Bash, we're using Bash as our tool, and we are going very much computer science light. So this is not like a computer science course, although I have taught plenty of those. We are looking at it from like a Linux administrator standpoint, and what do we need to know? Like if we wanted to get into maybe some scripting. So it says you are a new sysadmin for a company. You've decided that you need to start gathering system information so you could use it in scripts. You know that this will give you more capabilities later for automation and collection of system state. So you want to know how to use your tools better. Maybe you've been an admin for a little bit and you know how to, like, you know, see what's going on with the system. Like, you've learned these basic commands, but now you're trying to be like a little bit more in tune, let's say, with the idea of like automating something, right? Like I want to know what the system knows about itself. I want to know where these variables are, and I need to know like how variables work. So we're going to check our Bash environment for variables that we have as we start our system up. right? As we log in, we get a bash environment, right? Right, I've got this environment, but how does my system know that this is the process ID that I'm running and this is the type of shell, right? We called a variable here. We actually called a variable here. So where are those variables stored? Then we're going to create some variables, just arbitrary variables. We're just going to make them up and put data in them. And then we're going to output those variables to the screen, because if we can input variables and we can output variables, we've done 2 of the 3 things that computer science says computers do. Anybody know what the 3 things are? I just said 2 of them, right? Does anybody know what those 3 things are? Actually, yeah, we'll still need people to ring or yell at, right? When the shit hits the fan, for sure, for sure. Yeah, so there's input, processing, and output, right? We input stuff into a system, the system processes it in some way, and then there's an output. And that's like, those are the 3 things that, you know, CIS or computer information systems type degrees say that you do. Now, okay, do we subdivide those out? And yeah, is there a whole bunch of subcategories? Sure. But at the high level, we put inputs to a system, or the system gets input itself. There's some type of processing happening, and then there's some type of output, right? So this is going to look at some of that in Bash as it relates to Bash. And then it's going to tell you where to go for all the other deeper stuff. So I tell you guys all the time, you know, the way the human brain works, if you look at Bloom's taxonomy, how we learn is we understand like concepts. We understand terminology and concepts first. We need to understand what all the building blocks are. So you're going to hear terminology and see things. And the first thing is we're going to check our environmental variables. So Bash is set up in a way, right, where we can go and look at all the things that are in there. So we're going to do print env. And print env is going to dump a bunch of variables from our environment to the screen. So shell, working directory, login name, so the log name, what our home is of this user, a bunch of ls colors, which are then interpreted later so that we get cool little colors when we look at ls output. And then some other ones here, SSH connection if we came in from somewhere. And these are all the things that might be useful for us to know about this shell, right? But then we can also use environment, and environment gives us almost the exact same output. We can look at declare-p. So I give you 4 different ways to see the environment you're in. Declare-p will show you a lot of those same things and even give you maybe some other pieces of information about what's going on inside your system, what your history size is and your history file size. These are things that I didn't see from the other one. Where's the history file being written out to? So if I need to go look at the history file, can I look at it in real time, right? So, yeah, so schizophrenic, what happens is every user can configure from a base environment that they're given anything else they need. Yeah, so I'll get into that here in a second, but then we also have set. Set gives you the most, right? And if you didn't want to count these up, because counting these up would take forever, you could just do a little thing like this. So we're going to take all of those outputs, pipe them through, and count the lines on them. So 16 and 16, those were the same, and 64 and 65. That's how long the output was from a line perspective. So real quick, the question was about each user have their own environment. You can define your own environment in Linux. When you come up with a shell, right? So this is my shell right here, or this is my my process ID for my shell. When my user starts an SSH connection over and then gets a shell, what's going to happen is inside of my home directory, and let's see, who am I? And what is my home, right, without changing anything. So if I cd to root and I ls-a, I will see all of the hidden files. And in here I have a .bashrc. Now my .bashrc is going to determine how my system files are set up, how my environment is set up. And this is my file. So ls-al.bashrc. And I can see that it is owned by the root user. It is my file. It is 644 permissions for the, it's 6 right here for the owner of the file. It is 4 right here for the group owner of the file, and it is 4 read-only for everyone else, right? That's what these read. This is read, write, execute, or 421, and read, no write, and no execute, and then read and no write and no execute. So it's 644 the permissions that we have, for the root owner and the group owner, right? 6 is for the root owner and here, and 4 is for the group owner right there. Anyways, all that to say, this is how my environment was set up, was what's in my bash RC. So if I view my .bash RC file, here are things that were configured. I can configure this and reload this or resource this, as it were, and then I would get whatever those values are. But then we come down here and there's some things that I might do in here. Let's go look in here for, we're just looking through, We set some aliases, right? So we might set aliases to our system, so we can go look at aliases. Like, aliases are just shorter versions of commands. So when I type in the command ls, I automatically do ls color auto, and I assume all of those ls underscore colors that were in my definitions up there, right? So I come down here and this is it. If bash alias exists, so if in my home directory there's a bash aliases, we're going to source bash aliases. So if I wanted to not just keep a bunch of other aliases here and keep extending this file, I could use a .bash aliases file, which if it exists, they'll use it. They'll actually source it. This -f can tell us if it exists, right? And then this will be there. And -f is if it exists and if it's a regular file. If you ever need that, tldp.org, file test operators. This is one of the best little things. If you can't remember all these, I'll link this to you guys. I like this. So what is a -f? It is a regular file, not a directory or device. So if this was a directory or a device, this wouldn't do anything. I'll put this over here so it can rotate with all the other stuff over here. But file test operation is an important skill for you as you start getting into Linux, right? Now we come down here and our system is exporting the path that it wants to use. If I want to change our path to have a proper £sign like it should, I should be able to go right here and change that to a £sign. Because maybe I'm tired of seeing, even though I'm not going to save it, but even though I'm the root user, I have a $sign, which is kind of annoying because in Linux, most of the time a £sign means that we're at the root prompt. But in this environment only, it looks like something else. Can we look up this inside the man pages of bash or something else? Yes, schizophrenic. A lot of times what people will do is they'll copy environment files from other people, or as you do things and you find that like you need a new path or something like that, you go in and you edit your path inside of there and that kind of stuff. But this is not the only source for all users, these local files. There are also etc profile.d. These files are also sourced by all users right here as well, right? So you've got your, typically in here, if it exists, etc, and then also your, let's just view etc bash rc as well. I don't think you need the dot, it should just be bash. Yeah, oh, apparently it's bash rc in this one. And then if this one exists, then this is also getting sourced by the users as well. And then all users get this. But once a user's in their home environment, can they change it any way they want? Yes, they can. So that's a limitation. I mean, they can't give themselves permissions they don't have. They're going to bash themselves against that. But they absolutely have the ability to change the behavior in their own shell all the ways they want. So if you leave something open and just expect a user never to find it, that's not going to stop. Yeah, Linux definitely has a lot of control. There's been a lot of time put into it, schizophrenic for sure. Okay, so we did these things. We were kind of going and looking at some other places that variables and values get set and stuff, but I think that that's good to know. You are going to probably early on in your career do a fair amount of user support, and this is where you're going to dig in on a lot of this stuff. And then sometimes you have to come, like I've done a lot of user support over 22 years of doing it, so sometimes people come to me and ask me stuff, and I'll go dig in on what the users are doing or that kind of stuff, right? Sometimes you got to go look at where they source things from and all that. But you'll start to find the structure of like how bash scripts work by looking at your own little dot files. Dot files are populated from a place called etc-skel. In here, anything you put in here is going to be put in all new user directories. So watch this. I'm going to, just for fun, I'm going to say user add -m Scott. Let's add the user Scott. And if I cd into home Scott and I do a ls-a, I will see all of the same ones that are here. So I might do something like this. I might say ck-sum in here, dot profile, right? And get a checksum for a profile. And I'll go back to the directory we were just in and do a ck-sum dot profile. And it's the exact same file. Nothing's changed on it, right? So everything that's in there gets put in there. So then you say, well, Scott, can you prove it? I'm going to say touch dot dyno, right? In Etsy skill, right? And then I'm going to say user add -m Scott2, right? CD to home Scott2, ls-a, and there's that dyno profile. But there's nothing in here that's going to force the original one. So Scott, the original Scott, does not go grab that new dyno profile. So this is a limitation of Etsy Skell. It only applies to new users. Schizophrenic, if you want to do anything beginner, down in our Discord, there's a beginner start here section. So you scroll down a little bit. I know there's a lot of stuff going on in our Discord. There's a beginner start here section. It starts off with some like intro Linux type stuff. It starts with some free certs that you guys can go get to at least have something on your resume. If you have nothing on your resume, these are free certs. They are not even, we are not related to any of these organizations in any way other than we like free stuff. So there's free certs out there that you guys can take. Then there's a playlist for the Linux sysadmin course and the Linux security engineering course, so you can go watch that on YouTube if you wanted, right? And then here's the course book. So the beginner start here section is really good, I think, for people that want to get started. On the YouTube side, I didn't link that, but it's down in the description of the video. You can find that stuff. So anyways, so we're over here. We're adding stuff to the left as our normal system spins, but we also have prolog.org. You guys can go hang out there. That site should work for you and all that stuff. So I come down here a little bit and I keep scrolling, right? And I go look at, let's go look at a variable called name. There's nothing in it. Now what happened here when I echoed $name, my system went to basically a box with the label on the outside, NAME, name, right? So this is how we call a variable by name. That variable, that box had nothing in it, right? It didn't even exist until it went to look for it. So there was nothing that output to the screen. So that's not great. I mean, we're calling something that doesn't exist. So maybe we can put something in there. So maybe we use a command like uname, and uname by itself will give us the output of Linux. Okay, so uname is a command. By itself, it gives us Linux. With the option of -a, we get all this output. With the option of -r, we get just the kernel. And with the output of M, we get the architecture, which is super useful. That's super useful. We use this in scripts to make sure that things are the right way and things are working the way that we expect. But if I did this command here, I got uname, and it popped out to the screen, and then we captured it. We did this right here, this $, and then a open paren, and then a closed paren around this, is a common way to say execute these things, and then an equal sign in bash is not an equality operator. Equals is an equality operator. An equal sign is a assignment operator. So one equal sign is much more like a dump truck, dumping all of this down into name over here. So what the net effect is, earlier we had nothing in the variable name. Now we have something in the variable name, and it's the output of whatever this command execution was. It's a term called interpolation. It dropped it here and then put it over here. So I would expect, if I echo name again, to see the output of this command. Does that make sense to everybody? So echo $name. Now the box name has something in it, which is the word Linux, because it's what was interpolated from this right here. So maybe as I start talking about this, I do something like this. I come back up here and I say date, right? And then I say start, maybe we do some camel case, and I say start date equals this, and then we sit here and we talk a little bit, and I tell you guys about some Linux, and I wave my hand around while I'm reading my little book down there. And then when I'm done, I say end date, right? And then now I can echo start date. And I can echo end date. And I can have those two values 15 seconds apart or whatever. Pixel Kick said, any chance I can get a link of the source material textbook, please? Yeah, there are 2 textbooks that are free. This is one textbook that's completely free right here. I'll link it to you guys on both sides. This is to the Linux sysadmin course. And then this is the link to the security engineering course right here. This is also in our Discord if anybody wants it. Right? So you guys are welcome to use that. That's not directly what I'm working on right now. I'm just working on the labs. The labs are up in Killer Coda. They are also free. You know, everything around here is free except if you buy the one book. This book over here that's kind of scrolling around, this is our book that goes through the labs, and then it just makes you dig in a little further. It's the only thing anybody could pay for around here. Everything else is completely free, right? You guys are welcome to hang out. You guys are welcome to, I mean, we got over 4,000 members in Discord. You can ask them. I don't charge you guys nothing. You don't even have to boost the server. You can just hang out. We've had very few people in the history of our server ever get themselves banned, and everyone that's ever done it, if people know what was going on, probably think they deserved it. So, too big to fail. Yeah, all my videos go to YouTube. Yeah. Everything's on YouTube. Xshunny said, can you show that user uname creates a subshell? I mean, it probably does. I don't really... I mean, it's basically just running that and then dropping the output where it is. So, yeah, that's... Yeah. You guys might notice that Ranger Cam doesn't have Ranger anymore. Ranger... We had to take him down to the vet yesterday. He was in way too much pain. So yesterday was Ranger's last day with us. This will be the last day Ranger Cam's up. I just left it up out of nostalgia. You know, we miss the guy, but got to move on. I was hoping he was going to have one more 4th of July. We were really hoping to give him yesterday or today. We were really hoping, but he was... Guys, he couldn't even stand up anymore, man. Even heavily medicated, he couldn't stand up anymore. So we had to take him down. Yeah. Yeah, he was a good guard dog. Yep. We love the little guy, but if we had, me and the wife had talked about this. Like, if we could have, man, just keep pumping him full of drugs, right, and keep him alive, but. I mean, what is that worth for him? You know, that's like, I mean, he still couldn't stand up. He's still like, I mean, it's not even worth it for him at that point. Like, it's just, I mean, now we do joke around about how Ranger does love drugs, but you just can't be completely pumped so full of drugs that you're out of your mind. And that's basically what he spent most of yesterday on before we took him down. He was pretty out of it, and then that was probably the only time in the last year that he hasn't been in some type of pain. He had a lot of problems with his back legs and his back, so. But, yeah, Ranger will still pop up. Like, when people follow and stuff on Twitch, he'll still pop up every now and then. Because he's still one of our, when people follow, he still pops up. Depending, well, in some environments, he still pops up, I think. Let me see. Does he pop up here? We do have the Twitch alert box, so he should. Yeah. But only sometimes, right? Like, because it's like a 50-50 chance. I can make it 100% of the time, but... Anyways, all right, so we won't dwell on that because it'll make us sad. And Ranger wouldn't want us to be sad. So we see the output here, and then we go do this little thing that I kind of think is fun. This is a good understanding of how output is captured in a system. When you run a command, right? So we're gonna just hit this button real quick. Hit a couple buttons, and then we're gonna go back and look at what happens. So if I just run this PSEF and look for HTTPD. And then I echo $? I will get some number. Don't worry what that number is yet. But then I'm going to check for SSHD running. And I do see that it's running. And I'm going to echo $? And I'm going to get a different number out. And I'm going to go, well, what the hell is this $? Well, I'm going to tell you what it is. But you can also now that you've seen the behavior, this is true of most engineering. Now that you've seen that there's a difference behavior, you can ask why. And then we can go examine it and figure it out. Or if you've got somebody like me here to explain it to you, I'll explain to you what I know about it, right? And then you can always go dig in more later. But the point is, when we run a command and a command exits, this is the exit code of the last run command in bash. Well, the exit code or the exit value of a good, and this comes all the way back from C, when we exit good, and we exit with a good, so grep is the last thing that happens here. We grep for some value, and we found that value. So grep returned an error code of 0, or an exit code, as we often call it, a return code, RC, of 0. So that means that something was found. So now 0 in this case is analogous to we found SSHD running on our system. But the error, or the return code, an exit code of grep was 0. If grep does not find something, grep did not find HTTPD running on our system, then the return code of that command is going to evaluate to 1. And so now in this case, 1 is analogous to false. Most of the time, guys, 0 is false and 1 is true in normal engineering. But in this case, because of what we're doing, it's analogous to false and true that way. Does that make sense? So we're doing something here where we can take a value, we can take a check of something we did, and then get this error code out of it. And we take that error code, error code, I keep saying, but it's a return code. We often think of them as error codes because when we error out a program, we error out with a certain exit code for the specific error, right? And sometimes there's catch-all ones and that kind of stuff. Well, it's a return code. The return code is the technical term for it, right, in RC. But, and inside of bash, it's an exit, so you could also call it an exit code, right? But when we like capture it in other contexts, we call them RCs or return codes. Especially like if you use Ansible and Python, we call them return codes in that context, right? But anyway, so for us here, my point in showing you this is when I did these two commands, I set variables right here. Again, equals is not equality, it's an assignment operator. So it's assigning what the output of the right side of this is over to here. So from looking at this, we should expect HTTPD, right? This HTTPD tool right here to be a 1. So if I were to echo, right, with a $, I would expect this to have the value of 1 inside of it, yes? And if I were to use SSHD check, I would expect that to have the value of 0 in it. This is useful in scripting because let's say I could only install a tool if HTTPD was running. If I've assigned a variable now based on if HTTPD was running, like if I was writing this into a script right now, and HTTPD was not running, which it is not, then I could fail out the script, and as I did an exit code of 1 or 2 or 15 or 127 or whatever I wanted my exit code to be, I could also send a message out that says, cannot run this program can only be installed if HTTPD is running. That's a common one. Another one that's kind of common is this. They always check this. And if whoami does not equal root, the script will leave and say this script must be run as somebody with root permissions. So if you're not the root user, you need to be or we won't run. That's a very common check in the top of scripts, right? Especially scripts that are designed to work across multiple different versions of Linux and stuff like that. And what I would tell you guys, if you were like, hey, Scott, can you show us a script that does a bunch of checks? Yeah. I mean, yeah, if we want to dig into it, yeah. Watch this. So we're going to stop this thing from spinning. We're going to come over here to this version of our book, right? So we'll go to one part of our book here. And I need to come down here. Where was our Kubernetes? So our Kubernetes was in week 10, right? So we're going to come over here. I'm going to drop down to week 10, right? And in the in the lab, I make you guys install this tool for the K3's installer. Now, I'll link this to you guys if anybody wants to do this in like a lab environment. I'll just link it here and on YouTube. This is your risky click of the day, right? Let's paste this real quick. And watch what happens. It's going to throw that out over into temp. So now we're going to let's just view it. View temp K3. So we just downloaded that installer. This is the installer script, the installer shell for K3s, if you wanted to run K3s on a local environment. And I'm going to go look at it, and okay, they've got their shebang line at the top, their bin sh. Now, we're not necessarily in this lab and these other things dealing this deeply with scripting, but I want to show you guys how this all relates. They've got some values that they set up at the top, and you can look at what those all mean. But now we drop down here, they've got a bunch of change configs, and all that's commented out. But then they have some helper functions, so here's info. And we get down here, and they're going to verify some things about the system before they do anything else. And this is if sbin openrc-run is executable. And you say, how would you know that that's a test for execution? Well, the square brackets around something are analogous to the word test. And I sometimes show that in as we talk here. But this is a way that we do in scripting to test. And you say, well, how do you know what the -x is? Well, over here, if we jump back into our file test operators, -x right here is file has execute permissions for the user running the test. So if the user that's doing this could run this, then we set the variable has openrc to true. We're probably going to check that later. Now, you guys might say, well, Scott, couldn't you have done something like this instead of something so simple? Yeah, this is a cheap and like quick and dirty way over here that I did this in the lab. But this is the more structured way. If we start an if condition and we have a then we have to end with an fi. So anything we open in bash with if, we close with an fi, and then now we have whatever our values are here, right? And then this thing says down here, if executable bin systemctl, executable by this user, meaning you're the root user, then we throw out whatever we see. It also is going to test if, so this is testing, this is actually interesting. It's testing if I'm the root user here, or as long as systemctl is of a type, we could test that command, but systemctl has a type of executable, I believe. Let's go look at this real quick. I want to see this now. Yeah, systemctl is user bin systemctl. So then it validates that it's there. Let's look at this. Yeah. So it'll check for it to be there. And that's an or condition right here. This is an or logic. So this has to be true or this has to be true. And then it'll say has systemd. So if openrc is there, this is probably not going to be a condition on most modern Linux. Maybe some operating systems use openrc. Most of the professional ones are going to use systemctl. And then or it's going to come down here and say we can't run, buddy. And it'll say fatal, cannot find this, and it'll break out of the installer script or whatever. But then watch this. I want you guys to keep coming down here. You could keep looking. It's going to start just looking at arguments that you did. We didn't give any special arguments. It gives a case command right here, and it gives whatever the K3's URL is, which is going to be defined later. This is a function up here that's being called. And if it's HTTPS, it'll do whatever it's going to do. And if it's anything else, it's going to say fatal and say only HTTPS can be used. Then they've got different things down here with cases, but what I was going to show you guys is these are all checks up here still. We're just checking stuff. I wanted to see if we have Arch. So this is where it starts to set the architecture. And it's doing very similar to what we had right here. Hold on. Here's the whole case statement. Remember earlier we were setting variables. So here's Arch equals, and that's a equal sign, but it is an assignment operator. And they do a uname-m. Now you guys saw with me, uname-m is x86_64. So is it this? No. Is it this? Yes. This is the architecture of our system, AMD 64. And that's the decision that's going to be used all throughout this. If it gets to the bottom and the catch-all, meaning it didn't take one of those select cases up there, then it's going to come down here, and this is going to be the unsupported architecture, and it's going to kick us out of this script. So right here, I know that the things are getting more complex as we look at case, and this isn't even really what we're doing right now. We're actually going through the simple setting of variables, but I'm showing you guys they're setting a variable right here from the system. They're reading in architecture. Then they're looking through all the architectures that they support right here. These are basically just testing keys in a door, if you want to think of it like that. And we found it here, so we're good. We're going to keep going. And we're going to set our architecture to AMD 64 so that that can be used for the rest of the script. But if you got to the bottom and you were some other BS architecture, you're going to be fatal unsupported. Like you write your own script or you write your own, you build your own hardware or something, then this doesn't install on your hardware. That's all there is to it. And because it hasn't been tested by them. So my point in showing you guys all that is there's a lot to this, right? There's a lot to learn. There's a lot to get into, but you guys have the ability, right? Like in this one, we were just doing Kubernetes stuff, but you guys have the capabilities to get in here and start learning this stuff, start messing with this and all that kind of stuff. Use RISC-V, nice. All right, so over here before I went all far afield. Can you verify that they're correct? Yeah, we've verified that that's what we expected. And then which one is running and which one is not running. HTTPD is not running and SSHD is running. We see that. So we hit check. And now we got to do some decision structures of bash. Now, this is a computer science concept here, but since we're doing computers, right, we're in bash, we should be able to use either a single alternative or a dual alternative or a multiple alternative structure. We're going to test each of the structures with the variables that we have from the previous step. So we made those variables. They are correct. Let's go test them a little bit. In a single alternative structure, this would be like me walking home. I'm walking home, and I think to myself, if I see a stick, I'm going to pick a stick up. But guys, what if I don't see a stick on my way home? Do I pick the stick up? No, because there wasn't one, right? And did I ever have to change from the normal execution of my script? All scripts run top down, by the way, unless you change the execution order with a function or something, or some kind of other repeatable loop or those kind of things. But for the most part, scripts always execute top down and in sequential order, unless we do something to them. So in a single alternative structure, there is no choice that is forced. If I don't see a stick, I don't pick a stick up. So this is going to check that if HTTPD equals 1, then we will say that HTTP is not running. And it's not. And then we'll check to see if SSHD is equal to 0, and then echo SSHD is running. But let's do another one real quick. Let's say that I did, let's just say, if blob equals this, then blob is running. And I just hit this. Right? There's nothing in blob, but well, we don't have any value in there, so that's probably our fault. But we don't worry about that then. But the point is, yeah, schizophrenic. Not if it doesn't have a RISC-V. No, not with that. Not with that one particular installer script for K3s. You could not install it. No, that's K3s though, not K8s. K8s is much more robust than K3s. The installer script that we were looking at was only for Kubernetes Lite, which is K3s. I don't know the exact name for it, but it's a much lighter version of, and it's good for testing, but it's very, very bad for anything else. Yeah, this is kind of, I thought it would have worked even if I didn't. I could just instantiate, I could just give the value. But the point is, even if, so if nothing happened though, it didn't have to say anything. So if, let's say blob check. Right. Now, it's going to do that, but it's never going to do anything because it doesn't find the output, right? So then we come down here and we keep scrolling down, and it said, is this the output we expect? Yeah, we expected it to say it's not running, and we expected this to say it was running, but that was still, there was no forced decision. With an if-then structure, which is a dual alternative structure, we're going to force a system output. Something has to happen, even if the condition is not met. So we're going to make this a little longer, and we're going to add the else condition. So if this, else that. If this, else that. And on this other one, if in our blob check, right, we're going to say else anything else bad is happening, right? And we're going to get that value. We have forced that block of code to run one way or the other. Just one question from the beginning. Etsy bash rc command you ran. What was it? At the very beginning of the variables section? Oh, you're talking about, so more Etsy bash.bash rc. This is a weird Ubuntuism right here that it's bash.bash rc. I've never seen this before. It's always just Etsy bash rc. What this is, so this is a file that is then, I'll hit Control C on it because that'll be long. Yeah, too big to fail. So what this is that's a file that your system's gonna maybe source. So if I cd, who am I? I'm cd to root, and then if I grep from everything, right? From any hidden file. If it was there, do I not see that? Let's see, grep that, anything like that? No, you don't really need this around it. You don't really need the asterisks around it. But from anything, well, anyways, there it is. It says right here that we could source that, but this is commented, so it's not being sourced. But we could force that sourcing in our system if we wanted to for sure use that or not. Is that what you're talking about? And then how do you resource something? So let's say if I just do alias real quick. So this will answer a question that maybe is being asked here. So if we do an alias right here and we see that these things are here, I may say alias dino. This is one of my favorite ones to do. Echo. Right? So now, if I write dino into my system, it's going to echo out roar, right? But some of you know that if I were to reload this shell, or if I were to come over here, it's not going to be there, right? But if I write it over here, so we're on the same system, but we come over here, and I write that into my bash rc and shift G to the bottom, and I could just, again, I could just drop this right there. So now that's part of my alias, right? That is not going to be over here yet. But if I source my .bashrc file, meaning to reread it and reload it back in, now Dino's going to, oops, now Dino is going to be there. Because I've reread that file from the source and brought it in, all the variables and all the other stuff that it was going to do. And I've used that to pull in that dino command. Now if I type in alias, which it wasn't there before, now it is alias dino. And anytime anybody logs in as root on the system from then on, that's going to be an alias, right? If I want to get rid of it, I got to go comment it out there and also exit out. I can't unsource that. I can unalias though. Once it's a single shot, so I can unalias dino, and dino's gone now. But if I resource that, dino's back because it's part of that file. And it's being pulled in with all of this nastiness for escape characters and stuff. That's kind of funny. Anyway, so all that to show you guys that there's a lot of stuff you can do. So we forced something to happen here when we were doing this. HTTP is not running. That's true. It's not. And SSHD is still running. That's true. But then could we check that? Could we change that variable HTTP check to 1 just to verify? So if I say HTTPD check equals 1, I'm going to change it to 0 rather. And I'm going to say now run it, and it says it's running. Even though we're lying, we've lied to the system. But the system, we've validated that the two use cases for that are either 1 or 0. We don't have an option for something else. We're going to get it's running if it's not the 1 value. So that may be like a logical. There's 3 ways that we can have failures in systems, right? Especially in computer science. There's syntax errors where we just do things wrong, which I did earlier, some syntax errors. I do syntax errors all the time. And then there's runtime errors where we try to run something. That was like the blob check error that we had, where blob check it didn't find the values it expected, so it broke. So that's a runtime error, right? And then the last type of error is a logic error. That's the worst type of error because everything worked, but you don't get the output you expected. So, all right. All right. Man, we're already at 2 hours. So we hit check. Now we start to add an and or an or in our logic. So we add in a check that checks both SSHD to be on and the other value. So we set that value back to what it was, and we run this. And now we're saying if HTTP check equals 1 and SSHD check equals 0, then the system is good. The system is good to continue with whatever other things we were going to install, which maybe required no web running and SSHD to be on. Sure. And then we'll try some OR logic. The OR logic is going to be slightly different because now only one or the other one needs to be right. So I'm going to change that HTTP check back to 0, and I'm going to rerun that OR right here. And the OR should still say that the system is good, right? 0. Yeah. So, I don't know what's going on there. But, OR, then the system is good. Yeah. Yeah, we'll be fine. And then you can break them down and you can look at them, right? So you did some learning of Linux, you did some and OR logic, and then you can go find other useful information here. I'm a big fan of tldp.org. There's a lot of good information there, but they will walk you through bash programming and how it works and how you can write scripts and all of these things that you might use. Now, I will tell you, I mostly use tldp.org. I'll give you guys this link if you want it. I mostly use tldp.org as a reference. Like what you guys saw earlier when we were back over here and I showed you that, like, I'll go look up a file test operator. Maybe there's one that I just don't know off the top of my head. That's very possible. Most of these I use enough that I see them. But if you had asked me for, like, -s's file is not a 0 size, I wouldn't have maybe known that. I definitely typically know if it exists, right? -e, right? And then -f if it's a regular file. Those are, and -d for directory. Those are the ones I know, right? I use those more often. But the other ones, I got to know where to reference them. And that's the thing I tell you guys all the time. You don't have to be an expert that remembers everything. You guys just need to know where your reference points are, where you can go look. How is sourced bash different from exec bash -i? Well, if you exec bash, you're forking a bash from the one you're on, Shunya. If you just source it, you're changing your environment and your bash that you're in. So maybe you don't want to go a single shell deeper. Yeah, when you source bash RC, you're not executing a new bash shell. So the exec bash -l or whatever that is, I don't use that. So I don't know. I tell you guys all the time, I don't know everything. I just know the things that I use. So for me, if I don't want to leave the shell I'm in, which I typically don't, I'll just resource bash. I very rarely change my environment. I've told you guys I'm very vanilla. I will be as vanilla as an engineer as I can because I jump through so many different environments that I just keep everything the same. I'm not one of these guys that's going to tell you, oh, you got to change everything and do everything my way or you can't learn engineering. I don't believe that, right? I've worked with too many engineers doing too many different things over time, but I do think you can still drive towards the right answer, towards whatever. So yeah, Xshunya, I would just tell you, whatever one you pick, understand its behaviors and always do the same thing. Because I always use .bash rc. I don't use exec bash. Because I'm pretty sure that's forking a new version or a new shell. But yeah, I don't use that. All right, so we're going to go out of here. And we'll go back to our Linux labs, right? Linux labs are all free on Killer Coda. All their labs are free. We've done DNS. We've done, we pushed and pulled files. We did screen. We did DNS. We did some variables and logic. The next one would be conditional and counting loops. So we can do that here in a little bit. But probably take a little bit of a break, take a little walk around. So I'm going to pull up my little hourglass here. And again, if you guys have any questions or anything, let me know. We're just kind of hanging out and working through stuff. We're not being super rigorous with what we're working on today or anything. Let's go with take a break. Grab a drink. Walk around. Take a break, grab a drink, walk around. 10 minutes. Colchis is here. Oh, Colchis, I can't. Hold on a second. Hold on a second. Colchis has been around long enough here. Hold on. Rules. Hold on. Haven't done this in a long time. We haven't done this in a long time. Colchis, will you refresh your browser and redo that message you just did? Because you got commented out there, but if you refresh your chat, I'll stop my break for a second. I'm not quite on break yet. Colchis, can you send that message again? Oh, you did it on mobile? Okay, okay. There you go. Yeah, yeah. Now, Colchis, you should have permissions to send. There it is. Roadmap.sh. Boom. Yeah. I like resources like this when they show people, you know, what you guys can do, right? How you can go spin up your time. And I mean, guys, you only have so much time, right? You only have so much time in a day. You only have so many things that you can do. So you got to put your efforts where they're best used. All right, I'm taking a break. I'm taking a walk. Yeah, you got a little diamond now, Colchis. You're almost in charge of everything. I'll be back. I'm taking a walk. Alright, keep taking your break. I'm wandering around a little bit. We'll do some more labs here. Get a little more set up. I do need to clean up some of my lab environment I'm looking at there. Need to reboot some things, clean them up. Should be good. Alright. Oh, I get back and an ad's starting. Alright, we'll wait till the ad's finished. Well, we'll wait till the timer's up, I guess. Hang out. I know sometimes people are taking breaks and walking around and doing all that stuff, but we'll get ready for our next lab. Do some conditionals and counting loops. Again, these are real high-level concepts for computer science type stuff. But they're valuable, I mean, I guess in any language, but we're focusing on Bash side of it. So, also, I have a little bit different music today. I decided to use Pretzel Rocks, even though a lot of times on YouTube, Pretzel Rocks stuff is not approved, even though it's all approved on Twitch. Kind of an annoyance, a little thing that, from an admin standpoint, is kind of annoying. Like, I gotta go in and delete copyrighted songs for something that's supposed to be allowed. So, that's annoying. How to know how many subprocesses a script shoots if I have optimizing the script. Xshanya, you can look into when you're analyzing things, you can use strace to see what's going on if you're kicking off scripts. I actually have a few scripts running on a big supercomputer right now. I should probably go monitor them a little later today, but they are part of like this scrubber that's scrubbing out the Luster file system for older files. And what happened was somebody had already written a scrubber, but it was taking too long to work and it was timing out. So I wrote something. I couldn't change. I wasn't allowed to change any of the original process, but basically it was filling up too much. Does everybody here know what a Shishiadoshi is? This is what a Shishiadoshi is, right? I love looking at them. I think they're super fun. But if you've ever seen this GIF, let's see if we can just open in a window. This is what a Shishiadoshi looks like, right? So what was happening was his script was running and filling up all the way, and then sometimes it would time out and whatever was in there would just fail, so nothing would get deleted. Well, it's not a very good scrubber script if it basically goes in to erase everything and then it fails to actually erase anything, right? Isn't that kind of stupid? So since I was within the constraints of not being able to change that, what I did was as it was filling up and as it was gonna then maybe fail, my script comes along behind and kind of like cuts the basket or cuts the, see how it's filling up at the bottom? I basically have a little pressure valve that starts deleting things immediately. And the reason I did that, again, I had these constraints of what I could do, but I could immediately start deleting things out of the system and not wait for it to get all the way done with the find. And because I did that, I was able to greatly improve kind of the behavior of the final script. And so I also have to write up. I need to probably do that. Well, I'll do it next week, but I've got to write up a permanent fix. What I'm doing is what we call a stopgap fix, and mine took some exec stuff. I may get approval later on to bring it out and put it in the Discord for you guys to see what we were doing, but like it's just useful. And then if you're wondering what that thing actually does, that tool, that Shishidoshi there, every time the bamboo bangs on the rock there, it scares away like wildlife. It scares away deer and that kind of stuff. So, yeah, that's a Shishidoshi. That's like a Japanese thing. They use them. I didn't realize, like, so a lot of times in gardens, like, they don't want deer to come in and like eat their leaves or eat their trees or whatever. So they will use this and it'll keep the bigger animals away. I thought that was kind of cool. This will scare animals away. So that's a Shishidoshi, yeah. All right, I actually use that graphic in a what's it called? I have a different talk that I do on the filling up of buffers inside of Kinesis data. What is that? Kinesis data, whatever the one that for logging is, it fills up. Kinesis. What is it? What the hell's a Kinesis? I don't even know what that is. Kinesis, like data streams. Okay. All right. So let's keep going. We're gonna do conditionals and counting loops. So we're just gonna keep working through these. If anybody wants to do this lab with me, it's right here. Again, Killer Coda is, God, I think Killer Coda might be one of the best sites on the web, guys. It's completely free. They don't charge you nothing for it. All you gotta do is go sign up. They never even send me messages. They don't even like bug me. I'm gonna close this down because not really developer related stuff right now. All right, all this stuff's good. Okay, so we come over here, and we'll start it up, and it says you are a new systems administrator at a company. You've decided that you need to start using loops to increase your productivity and monitoring of the system. So create a conditional loop to watch CPU resources every 5 seconds, and then create a conditional loop to count to 10 with various different starting and ending numbers. Okay, we do that, right? That's a nice little challenge for us. You can try to do it yourself. You can go look things up on the web, or you can go look at the solution. And you might say, I know I've actually heard this before about the labs. You might say, well, oh, the labs are kind of easy. They just show you what to do. Well, because I'm convinced, right? Like, I'm convinced that somebody that wants to be an engineer and wants to be an admin, they want to see something work. And then once they see it work, they can modify it for their need. Like, real quick, I'm going to show you guys this. We're going to do this one right here. While true, do something, right? And this thing is going to loop. While true, do uptime sleep 5 done. Okay, good. So if you do that command, right, and we're sitting here talking and hanging out, smoking and joking and doing whatever, and I say, okay, hold on a second, hit Control-C to stop it, and then I say, wait a minute, could you change that, guys? Could you change that to, like, sleep for 10 and do the command, I don't know, maybe date? And you say, well, yeah, I think I could do that. I think I can make that go for 10 seconds. I just saw him do 5 seconds. And I think I can make that do date. And then maybe also still uptime. Yeah, boom. And I really do think, like, people that want to get into admin and engineering, you just need to see it working once. And then you can modify it for your own needs. You can go take that, like, you can go squirrel that away in your toolbox or in your Notepad++ or your OneNote or your Obsidian or, I don't know, whatever your tooling is. I think Obsidian's great. I think LogSec is great. That's LOGSE. Yeah. I think all these are great tools. And I think you can do that and then modify that for how you might want to do this. So then, as an admin, you might just kind of watch a server that's giving problems throughout the day to see what's going on. Now, are there other ways to do this? Absolutely. There's other commands. Like, people will tell you, well, you did all that. You could have just done watch uptime. But can anybody tell me what the difference is here? What's the difference between this and what we were just doing? I want you to look at that and think about it for a second. What's happening here versus what was just happening? What might I specifically care about that was happening here that is not happening in the other one? Well, this one definitely has historical data here, but the other one I only saw the 1 second. So the other one I have to be watching. This one I could walk away for a few minutes and come back, and I could see if there were any upticks in the 10-second mark when I check. Now there's limitations of what we're doing here. We're only getting slices of what's happening. There's another limitation to think about here. This is only something that's useful for an admin. You have to be root to do... Well, you don't have to be a root to do any of these commands, really, but you basically have to be somebody who can do Linux for this. But also the other limitation is right here on this side over here. We're looking at the load on the system, but we could, over here, if we wanted to, we could zoom in and actually see, we're looking at 7 days, maybe we look at the last 1 hour, and we can see how the CPU is doing on our systems. One of our systems is actually spiking system usage for P01 Jump 01. He's spiking usage, so that's a weird behavior for him. I might need to go look at what's actually going on that box right now, right? Like if I wanted to make sure we're not being compromised in some way, because there is something weird going on that server for all those spikes to happen. But over the course of 7 days, I don't even see that, right? That filters down in what's called our resolution for that. Now P01 Jump 01 is under a higher load than normal. So now I might come over here, start to dig in. I don't need a dash I on that. So there's nothing open in there. Because that SSH is just out over to the other system. Okay. We can go see what's going on inside the system, right? What's running, what's happening over here. Since July 01. Oh, you know what? I know it's spiking that. It's that damn Ansible playbook I'm running. Okay. Yeah, no, I was wondering what was causing these spikes. Anyways, all right. Sorry, guys. You guys will find out that I do all kinds of stuff if you let me. So we'll stop this. And now we did a thing here. If we look at our little while loop, super simple for what we wanted. And something to note about this is really, really good for adminning, if I just want to watch the system do stuff. But this is really, really poor computer science. Because right here, without the sleep, we've done a while true. Then we've got, so the structure of this loop is while true. We test the evaluation of true to true. And then we execute everything between the block of do and done, right? So this is going to evaluate the first time to true. And then it's going to run up time. And then it's going to get to done. And it's going to come back up here. And it's going to evaluate to true again. And how many times is it going to do that before it stops? Anybody know? Is it an infinite number of times? So this is very terrible computer science. To write a loop that does not have a break or an ending point is bad practice. But it's good admin practice. It's perfectly fine to say sleep 2 and then walk away and go to lunch or something and come back and check it when you get back. That's perfectly fine from an admin standpoint. It's not using a lot of resources on the system. It has historical data, so you can scroll up. You got a 10,000 rollback on your buffer. We saw that earlier from the other lab, right? We saw that we have this huge history. What was that? Declare P, right? Is that right? Yeah, declare P should show up here. We've got a rollback of how much history? Yeah. Oh, maybe it's only 1,000, but I thought it was 10,000. Anyways, whatever it is, it's we can roll back quite a bit. If we were to go to lunch, we'd be able to see all of these, see if anything happened. But now we're gonna make a while loop that's much more the way that we would normally want to do one. We're gonna set count to 0, and we're gonna set condition to 10. So we're setting count to start at 0, and we're setting condition to 10. And now we're going to evaluate while count is less than condition, do echo I am counting to count, and then we're going to increment the count and then done. And now the system is going to count all the way up from 0 to 9. That's weird. We set that from 0 to 10, but then in our test we said while count is less than condition. Now, so that means the last time that it could have run, which would have been when count was 10, is 10 less than 10? No. 10 is less than or equal to 10. So we could test this. We could mess with this a little bit, and we could say, well, wait a minute. What if we reset the count to 0, and then we change this to say less than or equal to condition, right? Now it counted to 10. Ah, wait a minute. Nope. Wait, so that's 10 iterations. That's 11. Now, if you were doing like a banking transaction or something, or you were counting up a number of users, is 10 users the same as 11 users? No. That's going to be a problem, right? So we need to make sure that when we write loops, we understand our test conditions, and we need to make sure that we understand how they're working. Now, over here we did file test operators, right? These are just file test operators, but they have newer than and older than. That's some nice stuff. But we also have other test operators. So I can go over here and I can say test operators bash TLDP, the Linux documentation project. And they have just simple tests here. So we'll go to test constructs. And then we come down here, and this is all the different tests of constructs that we have. But we should be able to look at them and learn more if we want to dig in. But over here, we should be able to say this. That was equal stuff. Hold on. We got our file test operators. Nope. I want to see, yeah, less than. Let's see if they have a breakdown somewhere that's real easy to see. If 1, then 1 is true, else 1 is false. So 1 is true. I need to find. I just want to see if I can find the less than and greater than. Sometimes they actually show them here. So here's our arithmetic tests. So walk you through greater than, right? 5 is greater than 4. 5 is equal, right? Double equal sign is our equality operators, as opposed to a single, which is an assignment. 5 minus 5, right? There's all this stuff. This one does not have exactly what I want. So I'm going to go back out to here, and then let's just do our comparison operators. Yeah, here we go. This is what we want. So this is really the next part of this, which is the less than. We did LT and LE, so less than or equal to, so that's important. You got greater than or equal to, equal or not equal, EQ or NE, and you could just walk through these and keep figuring out what your type of logic is that you want to do, right? So if you're writing a script, or if you're writing some, in this case, we're doing a conditional loop, we are going to walk through things. Then we get over here and we do a counting loop. So conditional loops are different than counting loops in one very specific way. We're gonna finish our counting loops up, and then we'll go figure out how they're different. But we're gonna create a counting loop that creates a loop to count over a list of numbers or items. I have 3 ways that I know of doing a counting loop. We can either give it a list, we can generate a list and drop it in real time, or we can read a list from a file. Those are the only 3 ways that I know how to do a counting loop. There are probably others, but those are the 3 that I've used, professionally. Those are the ones that I know how to do. So let's do that real quick. So create a counting loop over a list of numbers or items. Okay. So in this case, I just press in for I, that's what I want to count over, in 1, 2, 3, 4, 5, do, remember between do and done is our block of execution, echo, I am counting over I. The first time, that's going to evaluate to 1. The second time it comes through the loop, it's going to find the next item in the list, that's going to be 2. It's going to be carried through all execution in this block as that number 2. So then we say I'm counting over 2. It's going to come back through. The third iteration is going to be 3, 4, 5. Now, you might say, well, Scott, that's cool. I like that. But what if I said we have to do to 100 now? Is anybody still with me, or are you guys all going to leave the stream, right? Because that's not useful. Right? That's going to take forever. I can't even do that. Even if I had great dexterity, even if my 10 key was on point, that's too much, right? So there's got to be a better way. So what I might do instead is come down here. Oh, here's another one. We can count over a list of things that are not numbers. We're just counting over them, right? Cookie, cake, pie, whatever you might be interested in. Oh, hold on. Oh man. So my brother is up in. My brother had this trip planned for many months. He's up in Coeur d'Alene right now, and Coeur d'Alene is up in Idaho. And most of you guys probably heard that in the news in the last week for a reason, but that's not why my brother was going up there. In fact, my brother got up there 2 days after what happened in Coeur d'Alene just happened. But anyways, he just texted us a picture. They're doing a 4th of July parade out there. And he's like right off the main street. He got a Airbnb he rented out months ago, and it's just like a big, so like all these people are like out like planted on the street and all around, and then he's up in like his Airbnb with the kids and stuff, just watching the parade from where they're at. They're also looking out over a lake, so it's pretty nice. But yeah. Real quick though, back to the topic. We are looking at, as we evaluate what we're doing, we are looking at an inefficient way to tell a system to count over a list. This is great if you had a list and you just wanted to drop it in here, but most of us don't have lists like this. We either have large number systems that we want to do like a bunch of disks. Like I have 4,000 disks and I need to enumerate through all of them, and I have them in, I don't have them numbered yet, so I want to generate the numbers. Well, that's the next thing. We can programmatically generate numbers like this. So for I in, and I'm going to use that command execution that we saw earlier, and I'm going to sequence between 1 and 1,000. Now, sequence is an interesting little beast. If you say sequence as a command, and you just give it a value like 10, it's just going to count to 10. And then if you give it a second, so you put a value in before the 10, normally, so what it'll assume here is it'll assume its start, and then you're giving it its end. Down here, we're going to give it its start and its end, and it's going to count from 5 to 10. And then we can give it its start, and we can give it its end, and we can give it its step, which is general computer science, right? A start, a step, and an end. And now we're going to count every 5 between 5 and 50. So it's an interesting thing. If you give it nothing but just the one thing, it'll start counting at 1 and get there to the end. If you give it 2 numbers, it'll take them as the start and the stop. But if you give it 3 numbers, it'll count as the start and the step and the stop. And I think that's useful. It's useful to understand. You can also do a thing, this is very useful. Some of you are going to see the usefulness in this right away. We can also say, I want to start at 0, 5, and I want to preserve the width of this, right? This may become more useful if we do like, let's say like 20. Let's go 2 to 20. Maybe it's lowercase w. Yeah. So it'll preserve the width. And some of you might say, I don't understand why that would be important. Well, it would be very important if we were using like a fixed width file format for like JPEGs or something. If you're taking a bunch of JPEGs and turning them into like a time lapse or something, and the the coder or the codec that you're using does that. Oh, printf also, yeah. Printf is super useful for saving, but sometimes you need like 3 or 4 digit wide characters, and this is a nice way to do it here. This is the way that I do it in sequence, right? So, and then we could take this up. Watch, we could do this, and we can just wrap this just like this, just like we were doing there. And this is going to be our list, and we're going to say for I in. I is just a common counting variable. Do something done, right? It's done. And then now we just execute whatever we want in here. Echo I am counting $I, and then it'll loop through and it'll count them all up for you or whatever. Yeah. So that's another way. So again, we've got a generic list that we're typing in by hand. That's terrible. We let the system generate a list for us. That's better. But maybe you get a list of servers you need to iterate over, and you've just got a list in a file. So maybe something like this exists. There's a file, and we can cat out fruit.txt or something like that, and we have apple, banana, pear, grapes, or a list of servers, like in my home lab. Maybe I have the werewolf nodes. Well, let's do it real quick, and then I'll come back and do it. I can cat out fruits and then read those items. But this is the way I used to do it before Ansible. This is old Scott lore right here. Let's go bounce out to werewolf, and let's say I had vi. Let's go to cd temp vi sumlist.txt. Let's say, right, and in this sumlist.txt we've got Rocky 11. Rocky 14, right? There's no enumeration, so we can't do any of that stuff. Let's say Rocky 05 and then Rocky 01, right? So we got this list. And if we cat some list, we've got something. So I can say for server in, and then I use backticks a lot, but this is also a better way to do it. So cat sumlist.txt do echo I am checking $server. Oh man, I don't even know what's going on, right? And it would check the server, right? And then I come down here and I've already checked it. So now I'll go over here. Oh, what is going on here? Jeez. I'm gonna just widen this. I don't know what's going on in my terminal right now. It's super weird. Let's just go like this. Now I would just add this and then say maybe SSH to $server. Uptime done, right? And now I'll check each of the servers and I'll just grab their stuff. So some of those servers, like I got this from a manager, let's say. Some manager or somebody pulled out a service now, and I see that there's a problem with that naming. There's definitely a problem with that naming. These don't have that deeper, right? They don't have that full naming list like that. So now that's correct. So now I got to go correct the list. I got to go fix the inventory out of ServiceNow or whatever our CMDB, which is our configuration management database, because the objects in there are wrong. And you say, Scott, why would you go fix that? Guys, listen, I'm the dude that's going to be on late at night. I'm going to be the one that gets called out for something, and I'm going to have to go grab a list of servers and figure it out. And I don't want to be doing this and fixing this in the middle of the night. I'd rather fix it on a Thursday or a Friday and then know that my junior engineers aren't going to stumble. Because I'm telling you, you guys might think I'm kidding, but you're going to have junior people in your company. Some of you guys have worked with junior people. I'm not trying to shit on anybody. I'm just telling you it's going to be true. They're going to try to run some command in your thing, and it's going to break, and then they're just going to call you anyways. So you need to limit that. Now, for me, I would be like, look, guys, this is all you had to do. And I'm just going to go back to sleep while they're still on the phone with whoever's on the bridge call, right? But the point is, I'm just kidding, but no, I'm not. I would go back to sleep. But the point is, like some people, especially early on in your careers, people are a little scared to break stuff, so they'll just immediately go into like a back off and call somebody. And what you want to do is limit that kind of crap from happening, right? Anyways, I did all that to show you guys that you can loop over a list of things, right? And then in this case, a list of servers, and then you can say for server in, and you can hit those things. So this is super useful. Now, do we normally do it this way? No. But if it's some quick and dirty list that somebody gave me, could I still go pop it out like that? Absolutely. By the way, that server list is just cat root servers.txt. That's all that's in there. And then when we run it like this, it'll loop over and do whatever we need to. Problem is, and some of you would very quickly say, wait a minute, Scott, the problem here is this thing is kind of terrible. It's actually kind of terrible if anything breaks or anything hits a timeout. Yeah, no, sometimes we have to do this, guys. We have to do stuff like when I'm running against big lists, timeout like 3 or something. So if I know that the server's not going to get done in time, I'll let it time out. And I made even, this is also by the way, one of the reasons I use that echo. I am checking $server, because then the one that's by itself, if any one of them was not, if there was no output underneath it, then I would know that that was one that I needed to send my junior engineers to fix or whatever. Like, let's say like I'm doing a patching of a couple thousand servers in one night, and I have some of my junior engineers there to go be my low gophers, right? Because I'm running the major, patching and hitting most of the servers, and then I'm spinning them off to fix things, right? That's kind of common operations practice if we're updating systems. So, all right. Some of you guys might notice too, I was telling you guys earlier, yesterday was Ranger's last day with us, so this will be the last day that we have Ranger Cam up. But he has finished his guard duties. So, all right. So let's script a little bit of a loop. We've used some loops. Did anybody here think about or answer my original question? My question was, what is the primary difference between a counting and a conditional loop? There are a lot of things. I mean, obviously, like they're testing for truth or they're doing something, but there's a kind of, this is very much like a more philosophical. Why is a counting loop and a conditional loop different? What makes them structured? I mean, they're both testing for truthfulness or non-truthfulness or until a condition, whatever. But what's the difference between them? Yeah, to Brett, I appreciate that. Yeah. I'm not trying to get, too sappy about it, but I know a lot of people, for a long time knew about Ranger. So I know a lot of people are going to be sad when they hear about that. But it was just the night before last was just so bad for him. He fell a couple times and he couldn't even get up anymore, and that has happened over the last few months when he's heavily medicated. But it was finally it. It was finally it. Yeah, I appreciate that, Clam. Yeah. Yeah, me and the wife, we need to do something nice for him. I have like literally like probably almost a terabyte of like Ranger footage from over the years. That Ranger cam on him, so I'm gonna go through and pull like all the different kind of looks that he had, because he was all, that room was always different. You guys, people that have been around a while, remember we had couches in that room. We've had Christmas trees in that room. Like Ranger had all like the different seasons around him. Like the wife was always doing funny little stuff with his bed. He had all his different toys. He had all his little all of his little like Tux penguins. All right, can't crash out now. Gotta do more Linux. All right, the main difference between a counting and a conditional loop is this. In a counting loop, when you are counting over a list, some list exists, some thing or process or within the universe, we know that where the end is. Somebody knows that in a counting loop. In a conditional loop, we don't know. A conditional loop may stop now. A conditional loop may stop never. We don't know. Conditional loop could be conditionally stopped whenever or never. So in a conditional loop, we do not know when the end is. Nobody, let's just say nobody in the universe, let's just say, knows. But in a counting loop, something does. A list or me or, whatever. A counting loop always has a finite end, if that will. A conditional loop can have an infinite end. And it can never end, as far as we know, right? I mean, until time and until the systems break and stuff. So my point in bringing that up is that kind of can govern how you want to do things. If you know, or a process knows, or a list knows when something can end, a counting loop will do. If nothing knows, and we're waiting for a condition to stop existing or start existing or whatever, that's when we're going to go for our conditional loop. Looking for the condition that we don't know. Again, we don't know if the condition will ever exist or not, but it might, right? So that's the main difference between them. And that's very much like a computer science philosophical thing, but it's true. It really is. And the more you use them, the more you're going to be like, oh, that's interesting. Yeah, that's a real interesting thing. All right. So we use some loops. We've decided we're going to create a script that uses both type of loops to create 100 files on both of our servers. So create a script that loops over a list of servers, logs into them, and then creates 100 files called temp file 1 through 100. All right. So we're going to cheat a little bit. We're going to vi temp, maybe some script, or in this case, we need to make it called root file create.sh, right? And in here, we're going to paste this value. So what is this script doing? All right, what is this script doing? It's got a shebang line at the top. Shebang lines aren't strictly required, but we do it for, good practice. The interpreter we're in is already bash, so it was going to try to do this in bash anyways, but if we wanted to try to interpret it with Python or something else like that, we could do that up here, because sometimes you write like a Python script and then somebody runs it from a bash shell. Extremely popular and extremely common, so we would put that up here at the top. But in this case, the interpreter is the same one that we're using, so fine, good. And then down here we said for server in, and we catted out root servers.txt, which is the file we just made. And then we're going to SSH into each server, and in each server, we're going to then do a counting loop where we know that we're going to count to 100, and we're going to just touch temp file whatever, and then we're going to be done inside that loop inside of our command, and then we're going to have this command out here. Counting loops do need an iterator if, a counting loop has an iterator built in. So by nature, counting loops always count over something. Yeah. So like the old C structure is always a start, a step, and an end. Like if any of you guys remember that, or if any of you have ever done that, any C type programming, it's start, step, end, right? It's like also like basic computer science. We can do that inside of Bash, but the reason I don't show you that, and the reason that's not part of this lab, is that I don't really use that. I always count over some things. I'm a systems engineer. I'm a platform engineer. I'm always touching a server or a file system. I deal with things that exist, if that kind of makes sense. Some of you guys are going to find yourselves doing more computer science-y stuff and research and that kind of stuff, and you may be pretending things do or don't exist, so you may need to do other things. But for me, like I'm always dealing with a list, right? Something like this. So that would be actually that would be a limitation of me. I don't do that enough to know that right off the top of my head. Could we look it up though, real quick here? I'll show you guys how to look it up. So TLDP bash. Let's say counting. They will show you in here. I'm 100% sure. Not counting. Let's just go loop. And then in here in TLDP, they'll have the loops. And I can guarantee you they've got this other method, which I don't really use. So if they're counting over numbers. They don't have any of that. Try 4. Where are all the for loops at? All right, so here's the for loops at the top, and they're just looking for over a bunch of things. But let me see if they have for. No, for file in, and then they look at in the value. I don't see. They might have. Let's see. Again, I don't do it this way because I'm not a. While I understand some of this stuff, I don't do computer science professionally, all day, right? They're doing the same stuff. Here's one right here. So they're doing a C-like syntax here. So this is, again, not my way of doing this, guys. I use sec all the time, SEQ. Yeah, I use SEQ all the time. But this would be this is very much a C-like way right here. So if any of you guys need this one's here. Boom and boom. Yeah. So you could use this, and then you can give a limit of whatever. So this is the start, the stop, and the step, and then limit would be, in this case, 10, right? So start, stop, step. And then this is the step here is iterating by 1 every time, counting up. So start A at 1, A is going to count up 1 every time, and then it's going to have a limit of 10 that you set. Again, guys, this is not my way. That's not my way of doing the syntax. And I don't use a whole lot of counting loops for this similar type of reason. I tend to be counting over things that I already know, like a list, right? But that is something, this is absolutely something that you could do. And, oh yeah, look at this. You could use a C comma operator. Guys, I don't do 2 variables at the same time. That's wildness, right? This is going real deep in the weeds to stuff that I don't normally do, because I don't normally need to count over 2 things like that. But there you go. Interesting stuff, but not necessarily my bag. All right. So we've written our little script, and then if I were to try to run it, right? So where am I at here? I'm in root. So I have a file create file. And I try to run it. It's not going to execute, and there's a permission denied. Well, the permission is denied because the file is written as 644. 644 is typically and very commonly a default for file system creation. You can change your defaults by changing your UMask. My UMask on this system is 022, so that produces files that tend to be 644 in this case, and they do some anding between the bits and that kind of stuff. Crash System said, "Why must IPSec be such a pain?" Yeah. Oh, guys, hold on. My thing is busted. Hold on. My voice thing wasn't working, so I apologize for that. I don't know how long that's been busted for, but anyways, let's fix this to now have the proper permissions. Let's go look at the permissions. They are now executable, and now if I go up and try to execute that, it's going to do what it said it was going to do. And then if we go and look at what it did, we can go see that for server in the 2 servers, so we went back to that original method that we don't use very often. We SSH'd into both servers, checked the host name, and then we looked at all the temp files and then did a word count on them, so we let the system count them all up to 100. Crash, are you setting up IPSec between 2 devices or with Linux systems? Because, yeah, IPSec can be a challenge. Also, make sure you're using the same mode between the 2 systems. That's always fun. There's two primary modes for IPSec, right? I think the one's called authentication header and the other's full tunnel. One only encrypts the whole thing. The other one leaves it, but adds an authentication header at the end of it, right? So site VPN between 2 boxes and the link breaks under header. Ah, okay. Yeah. Well, that's also annoying. But if it's working and then it's breaking, that's an interesting thing. There should be some kind of, we should see something filling up, right? Some kind of buffer or some kind of thing. If nothing's working, then that's annoying. But IPSec, yeah, in general, can cause some issues. All right. So did we see our output? Yeah, we saw the output we expected. We did all the things. So if you did that lab with me, guys, you touched a lot of things that you can go and contemplate about. There's a lot of things in there that, you know, maybe you've never seen before or never thought to use. But there's a lot of ways to make your system do things for you and do things automated by iterating over lists or other things like that. And you can start to really gather some good information and get to kind of understanding the system. So, all right, where are we at? We're at, oh wow, I just hit 3 hours. We just finished the conditional and counting loops, so what we'll probably do, we'll probably call it here, and I'll take a break for the rest of the day. But this weekend, I don't have any college to teach this weekend, so I'll probably be on tomorrow morning, and we'll do part 3 of this, and we'll keep going through these, and we'll get through all the software package managers, the NFS and Apache, some of the Grafana stuff. And then after that, we start down on the, these are all still system configurations, and then we'll get into security stuff. So we'll have a lot of stuff to do. Remember, you guys are always welcome to hang out down in the Discord. We have over 4,000 people down there, and the goal of our Discord is to get you guys into doing this stuff professionally. I don't want you guys to think like, oh, the goal of the Discord is just to hang out and talk tech. It is sure. But for people that are like interested in doing this as work, I mean, guys, there's a lot of places on the internet to hang out, right? Like we can all go hang out on Reddit and talk shit and look at fun stuff, and there's all kinds of stuff to do to interest you. But our goal, my goal, and why I go live here is to get you guys doing this stuff professionally, because I really think most of you could. I really think all of you could. Anybody that sat here and listened to me for any amount of time before going, God damn, I don't want to see another command line command typed. Anybody that can sit here and do this with us probably would be able to do this if they wanted to. So there's that. Yeah, Akshunya, my next course is going to be on automation. Yeah, the next course I'm going to run, I'm actually going to try to get, I know Michael Pesla's super busy with his, he's got a baby coming and he's working on his master's, but I'm going to try to get him and maybe even one other guy that's like working primarily in automation to do some other like modules within the course. But I'm going to do a big one that's on Ansible, and then I want them to do some of the other stuff that they're also doing, probably around Python and some of that other stuff. Because like, guys, I can stumble and put together some Python stuff as much as the next guy, but that's not what I do professionally. Some of the guys in our group do that stuff all the time. So yeah, Akshani, yeah, and my goal is to get the memes going. I want the meme farming going. So yeah, there's good memes up there too. So I appreciate you guys all coming. Let's go to our little end of stream. Anybody that's hanging out on Twitch, I'm gonna go find somebody to raid. Let's go raid over somewhere. See if there's anybody that we're following that's doing Linux and systems type stuff. Let's go raid over to, oh man, do I have anybody in our same category? Who's doing stuff in our same category? I do want them to be in English. Jeez, I'm looking at a bunch of them there in other languages, and that wouldn't be as good for most of us, right? Let's go similar size. Anybody doing stuff like us? Guys, I don't see anybody doing anything fun not in the Linux space. So I'll tell you guys what, we'll just call it here today. I'll be back on tomorrow for sure, and we're just gonna make this part 3. There is a part 1. It's over on YouTube, so if you guys want to go look at any of that stuff, you can. But I definitely appreciate you guys coming, and I will see some of you guys tomorrow. Take care.